Okay, good morning, everyone. My name is Gavin Masterson. You'll see Andrew Collier is with me, and we are from Fathom Data, and we'll be running this tutorial this morning on an introduction to Git and GitHub. So welcome. I am just trying to confirm, Andrew, you say, is everyone here? I see 12 attendees in the room, so I am guessing we are a few light at the moment. I'm not sure if there's other.
Kevin, I'm seeing 24 people, so I think we're good.
Good. All right. And my screen is lying to me. All right. That's great. Well, thanks everyone for joining us. A couple of just general announcements. This is a tutorial, so interaction is something that we would like to have around the content that we're delivering today. So it's not really just a case that I expect to just talk the entire time. If you have any questions, feel free to ask questions either in chat of Andrew or anyone else monitoring the chat, or you can raise your hand and we can stop and we can answer the question live for the tutorial. So please feel free to do that. I would encourage you as well. This is a sort of more of a classroom type feeling than a sort of me presenting. So if you would like to, and you feel comfortable to turn on your camera, please do that. It's always nice to just sort of have a bit of interaction with the humans on the other side of the screens, and you're welcome to do that. The other small thing that I'll mention is that if for any reason my sort of shared screen is kind of being constrained or squeezed, there are options to sort of move the sideboards on the display out the way to make the screen larger as you're viewing it. See if you can find those. You can minimize some of the chat and the other options. So, all right. And yes, are there any questions before we get started? Because there is a little bit of setup that we're going to do now in terms of getting everyone set up on Knack and a few other things. But if there's any other questions before I start, does anyone have anything they want to ask now? No. Perfect. Then, if you didn't receive an email this morning that contained your password and the details for how to access our training platform called Knack, then please would you mention in chat that you didn't receive the email. It came to the email that you used to register for the UseR 2022 conference. So please check that email if you haven't seen it. The Knack platform essentially allows each of us to log in as our own user. So you each have a unique password. And what I'll do is just quickly show you here. Essentially, if you manage to log in, you will go to knack.fathomdata.dev. You'll be greeted by a login screen. Let me just do it here. You'll be greeted by a login screen. Scroll down until you find your username. When you select your username, you'll be prompted to supply a password. So in my case, I've selected this. And once you connect and you enter your password, what will happen is you will be essentially, you will open up on a virtual desktop inside Knack. So it's important that everyone can log in because the functionality, for which the content that we've prepared, it relies on everyone having a sort of clean and similar setup so that we can all do the same things and we all know what we're experiencing when we do these things. So if you can't log into Knack, please do let Andrew know in the chat and we can help you sort that out. All right. I'm going to hope that silence, unless my chat is lying to me and there are frantic messages, I'm going to assume silence is a good thing. And while we're here, if you've logged in, let's just quickly just discuss what Knack is so that you understand what's happening while we're doing this this tutorial today. So NAC is a virtual machine, and each one of us is essentially logging into that virtual machine in our own workspace. What you're seeing here is the desktop for your workspace, and all of these programs and the other components, including the content for the tutorial, can be found on your desktop. It may be laid out slightly differently, but it's like your desktop on your computer. You can arrange it how you want so that things aren't in your way or wherever you want them to be. But when you open, for instance, the Git introduction folder, you'll see that there's docs, labs, and slides folders. And the slides that I'm going to be presenting to you today are provided to you. If you want to follow along in your virtual workspace, you can follow along on the slides, looking at them if you're not looking at my screen or you don't have access to two screens. So please feel free to open that. You can resize this window as you need to, move things around when you have the terminal window open next to it, etc., etc. If the sidebar is open and you want to make it larger, you can minimize that. So that's generally, this is your desktop. What you do affects you, and it won't affect me. And so you can really set this up how you'd like it to be for the session today. The same is true of in the documents folder. There's a notes document, which essentially contains, and then like a notebook of commands as well as instructions that you can use if you're getting confused about anything. Maybe we're having a break and you want to read some things, get a bit of extra information or set things up on your computer in the background. The documents PDF is, HTML is where you want to go and look for that for now. And you'll find a whole list of instructions that will help you set up what you need to and understand what's going on and what you need to look for, etc., etc. So don't overlook that. And that will be emailed to you after the tutorial, so that you have a copy of that as well. Right. And then the other thing about NAC, just to understand what's happening here, is that we are going to be working within NAC, and we're going to work a little bit outside of NAC when, for instance, we access our GitHub profiles. If you haven't set up a GitHub profile, don't worry, we'll give you a chance. But when we're working outside of NAC, any information that we would like to bring into NAC in a smooth process of sort of a copy-paste just requires one extra step. Essentially, for instance, what we need to do is take whatever your, I'm going to copy this address here, this URL, and it's now on my Windows clipboard. But to get it into NAC, what I have to do is I have to open this little menu on the side. And what I need to do here is I need to essentially paste it onto the clipboard in NAC. And once it's pasted and visible on this clipboard, it will then be available for you to paste into something like your terminal. So for instance, if I were to open my terminal and I were to paste, you can now see that because it's visible here, it is now pastable in the terminal. So when we are pasting, for instance, your personal access tokens or anything else we use, then we will need to take this process. And the same and the reverse process happens if you want to take something out of NAC into your other workspace. All right, so that's just a brief walkthrough of what's going on here. If you get confused, please shout. Andrew's there to help you. He built the system, so he's the best man to ask. All right. So, without further ado then, I am so glad to welcome you to our tutorial on Git and GitHub this morning. I must say that I am standing in for a colleague of ours who did a lot of the preparation of this content, Amira Abrams, and I have worked with her, and unfortunately she's unable to give this presentation today, but I must give her credit for a lot of the stuff that you will see today, the flow, and various other ideas that have been designed by her, and I am now presenting it on her behalf. And so together we're going to explore Git and GitHub, which are becoming essentially the de facto go-to version control system in the world of programming, code development, and project version control systems. And so I'm really hoping by the end of this, you will find that you now understand, maybe you've never used Git before or GitHub, And I really hope that at the end of this course, you will understand both the benefits and the importance of version control in general. You will become comfortable using Git commands so that as you become more familiar through the course of the tutorial, you'll start to feel like you can take this into your own projects. You can start to experiment. You're not afraid to sort of use commands. You know that version control systems protect you from some of the mistakes we make as humans. And I really hope that you will feel inspired to start using it. The tutorial outline for today is going to run through a sequence of, mostly you can think of it as an introduction and then the hands-on, get your hands dirty playing with Git session. So we're going to discuss the background of version control, why we need it, what its benefits are, how it helps us. We're going to discuss specifically why Git and GitHub are different and what makes them special. And we'll look at some basics of Git before we then take a bit of a break, make sure everybody's set up to actually start playing with our own version controlled project, which will be a toy project in this case, but hopefully you'll be able to see quickly how it scales to a real project if you want to use it, maybe later today, this afternoon even. Some other notes just to remind you, the session will be recorded and will be made available after the tutorial session is finished and made available publicly. You can please keep yourselves muted during the tutorial for ambient noises, but please don't hesitate if you want to ask a question, to raise your hand and interrupt me. I'm very happy to pause and help people where they are at, because it's sometimes easier for me to understand what people might be misunderstanding if people ask me immediately. And then I don't carry on confusing people because they're not following what I'm saying. Feedback's always appreciated, both in this tutorial as well as afterwards. You can reach me on either my Twitter or email, and you can definitely just let us know what you enjoyed, what we can do better, anything that didn't make sense, or maybe you haven't received anything you wanted to receive after the course. So let's begin. If you're here, you've probably worked on a project, and the project may have run for, let's just say, a long time. It may feel like a long time, or it may have actually been a long time. But what happens is, while we're working on the project, we are invested and we start the project. We start to get deep into what's happening. We have our ideas and our brainstorming. We're in the flow, as they call it. We're doing all the work and we've got ideas and we're seeing things happening. And what happens is we kind of, without a version control system in the mix, you kind of end up having multiple files. Maybe you send to a collaborator, the collaborator sends it back to you. There's edits on the file. You don't want to overwrite your old file. So sometimes you develop multiple names for the same file. You end up having different versions. And occasionally, sometimes mistakes are made and you overwrite an old version that maybe you didn't want to overwrite, and now you're not sure how to recover that. And over time, what can happen in these kinds of situations, and I experienced this personally with my own PhD, is that it just starts to feel a little chaotic. There's a lot going on, and it's hard to keep track of everything that's changing. So, while you're working on the project, that's slightly manageable. But let's say, for whatever reason, you need to step away from the project. So you step away and you continue with something else you need to do. And 6 months later, when you come back to the project, it's not so great. Now you don't have all the benefit of being immersed in the project, and you don't have all those sort of short-term memories of exactly what was going on, or which ideas had been thought about and discarded. Maybe you've lost, some of the data itself. Maybe it's no longer available, or maybe it's just that the software that you're using doesn't really work with the data as it is anymore. There's a lot of things that can go on. For instance, even maybe the final version of your report is not actually the final version according to the last file that was modified. So this is not an uncommon experience for many people who work on long projects. And what we are talking about today is to try and help us move away from this kind of feeling of chaos and to give ourselves that sense of peace and security when we're working on a project, that if we're using version control like Git, we can have peace of mind that if we are working properly in the present, when we come back to the project in 6 months' time, we have a much smoother time picking up from where we left off, because the timeline of our project is recorded for us. We can see what's going on. And if we have any questions, as you'll see, we can ask questions of the log of the project. So just to reiterate again, when we are using something like a file, date, and time system for managing the most recent versions of our project, this becomes unreliable because different systems will modify the time of the file in terms of maybe it was just opened, but maybe it was edited. We don't know which unless we have some kind of version control system tracking the changes. The other problems that can happen is we're not sure what always changed, and we're not always sure then sometimes, unless we've written comments in a document for ourselves, not always sure what sort of issues we were grappling with when the file was in this state. And this can create problems in both code or documents, any of these kinds of systems where the information that we have needs context. If you're collaborating, it's maybe you remember things, but your collaborators don't. So it can be very difficult to remember all that was going on at that time. And that's where version control will come in. So if you've never heard of version control, the idea of version control is essentially a tracking system. It is a structured system to allow us to work the way humans do. We can have ideas and we can, follow little thought, trains of thought down a certain path. Maybe we discard that idea and we say, that's not going anywhere. Maybe we keep that idea and we say, this is a good idea. I want to get this involved in my project. However it happens, the tracking and the managing of the changes to files happens within your version control system. And there have been several versions of this over the course of the years. They're essentially always designed to help with collaboration, tracking, restoring old versions of your files, and to work as a backup if they're working on a cloud remote. So that essentially they create security for you in the project. As you'll see with Git, there are different philosophies to version control systems, but essentially today we're going to talk about the ways in which you can use Git and GitHub to organize your code or project. It could be reports or documents locally on your machine. You can work on it as you would like to, create incremental changes, and you commit these. If you never heard of the word commit, that's a term in Git that we'll talk about today. You can push or back up your changes on a remote repository, maybe in the cloud, maybe on another computer. You can pull changes from someone else's work that they've done onto your computer. So for instance, if Andrew's been working on something that we are collaborating on, and he makes changes while I'm not working on the project, but I need to get up to date, when I pull those changes, my local files will be updated with the latest versions that Andrew left in the repository. We then also have a sort of a way of ignoring files. So let's say you want to be able to write yourself notes and leave yourself little pictures and doodles or anything else the way you like to work, but you don't want all that information to go into the version control system so that everyone else has to download it every time they use the remote repository. You can also ignore files. And that's a very handy feature for many reasons. There's many things you might want to avoid including in a repo. And we'll show you one example as a toy where maybe your password is in a text file, for instance, or something else, and you really don't want to be committing that to the repo, otherwise everyone would have access to it. Sometimes large files will slow down the repository, and you want to ignore those too. So if you would like to, and you're following along on your slides, the Git cheat sheet that I mentioned here is shown here. It's useful always to think of the commands that we'll be using as tools. And so familiarity is going to help you a lot. So having this open in the background, if you want to, is a good idea, because if you're getting confused as to what I'm talking about or you want extra context, a Git cheat sheet is always a useful thing to have open. So if you click on that link, it will open inside NAC. But if you want to copy and paste it out through the clipboard to your own computer system in your own browser, feel free to do that. Let's talk about Git now specifically, because what I've been mentioning is like generally the idea of a version control system. And there have been previous versions of systems that were designed. But Git is a more recent addition to the version control system universe. And it's kind of, in the way it's sort of styled, it's a second generation version control system, because older systems almost had a copy paste approach to version control. In other words, you would copy all files into different folders, and those folders would represent the different versions of your project. But this is quite expensive if you think about it. If you have a big project, making multiple copies of a big project obviously gets, quite large quite quickly. And Git uses a different approach. So Git's approach to tracking changes is both faster and more lightweight. You'll see how quickly it works as we go through the tutorial, and it's hard to overstate how useful it is to quickly be able to check out a state of a project that was 3 years ago. If you're using Git to travel through time on some really long-running projects, it's instantaneous or near instantaneous to check out a file that you last had the version on your local computer 3 years ago, which is an incredible thing. The commit messages that Git stores in the log of the timeline of the project, they're very important for context, and we'll be talking a lot about what makes a good commit message. But the key part is that humans don't always get everything right the first time. And a version control system like Git, one of the best things about Git is that you can conduct safe experimentation and testing. So maybe we do have a crazy idea, like my code would definitely work better if I do this. Well, you don't have to risk breaking a working version of your project. Git will allow you to do experimenting and testing in safe ways. And then if it works, you can join it and merge it to your main project. And if it doesn't, you can just let it go and delete the branch that you're working on. So we'll see a little bit of that going on, but I hope you understand the implications of that, because it's always nice to feel like we can't break something when we're working on an idea. Why GitHub? Well, GitHub is you've probably heard of it, particularly if you're in this tutorial now. Essentially, GitHub is a well-known, almost open CV for programmers and developers. It's a cloud storage sort of remote location where people can place public or private versions of projects they're working on. And it's kind of like a sort of backup storage system like Dropbox, but with better features, because it's got the built-in version control system that's built on Git. And as I've been saying ad infinitum, essentially the collaboration aspect of a public profile is hard to overstate. Many people would like to see a GitHub profile if you're interviewing for a coding or programming job or a developing job. It's a very nice way to demonstrate skills, to create a portfolio, and it allows people maybe that you've never heard of to also find your work. So let's say you're working on a project that someone else is interested in. If your GitHub profile makes that repo public, people can find it and maybe even contribute. So maybe they're working with it and you don't know there's an issue, but they do, and they can report the issue to you. GitHub is the sort of like portal where these kinds of communications can take place. And so it's very, very useful. And I've really enjoyed getting to use GitHub myself. And it is something that I hope by the end of this, you'll have a lot of confidence to use both publicly and privately. And maybe you'll even feel like you want to start contributing to some open source projects once you understand how it works. So maybe you're sitting there and you're thinking, I mean, we're at the Use R conference, so probably we're mostly R users here, but Git is not something that is an R tool. It is, as I said, it's a version control system. So anything that you do that you would like to keep a record of over time, of the different versions of those files and projects, you can use that inside a Git repo. You can place documents, Python code, R code, Rust, anything you want to do. Essentially, you can mix languages. You can, a lot of people will you'll see it be the R packages that you know. If you want to install from GitHub, often it's a GitHub public repository where the package lives. There's many, many different ways you can use this. And I've even said that the no code project there is essentially this idea that it can just be your report. It doesn't have to have any code in it at all. So Git is useful for almost anything that requires us to understand how things are changing over time. Let's talk some basic terms quickly. The terms that'll be the sort of most important to know during this tutorial and to get familiar with are things like a repository or repo. A repo is essentially, if you think of a file folder, it's a file folder that Git is aware of and tracking files within. So a repo is not just an ordinary file folder. You turn it into a Git repository using a Git command. Commits are an important sort of component of essentially taking a file in our working directory and making sure that Git takes a snapshot of the version of that file. Pushing and pulling is kind of like, think of it as upload and download. It's not exactly that, but it is equivalent. And branches. So branches are a very important feature of Git. And it's easy to overlook their use when we start out using Git, but it's something that I hope you will really pay close attention to when you're working on a project. Branches are something that you can create multiple branches in a day, work on ideas, merge them or delete them as you need to, and carry on. Branches are a very, very powerful tool within the system of Git. And so we may not get to demonstrate all the power of those, of how branches work, but in our work at Fathom, we do a lot of branching, and then we only merge stuff that is actually successful. We don't obviously just work on main branches and development branches and things like that. We use branches to manage our workflow. Pull and merge requests. This is a kind of a know your Git versus GitHub language. Pull requests are a GitHub specific term, and I'll explain why they're called pull requests when we get there. But in general, merges or merge requests are a like GitLab or a Git term. The actual Git command is called git merge. And then issues. So issues is a great way on a project of just keeping track of what's going on or wrong. In other words, maybe someone wants something to be added. Maybe you work on an R package and you really would love to see a feature added. If you go to the issue board of that GitHub repository, you can look and see if anyone else has requested the same feature you would like, and maybe you can ping that and say, yes, this is brilliant. I love this idea. I'd love to see that implemented in this package. And then the package maintainer will know what are the most popular things or which bugs are the most common in the package, and they can fix them. All right, so if we just talk for a second about the GitHub side of things, when we are looking at GitHub, I've mentioned the word public or private repository. A repo can be public in the sense that anybody can see it. This is essentially like what you would find if you go and look for an R package that's on GitHub. You can see everything. You can't do anything to the repo itself, but you can see all the code and you can see how it's structured and you can see layout. Maybe you can see the notes that Hadley's written to himself or anyone else has written to himself about what's next or what they're working on. And so the public repository is what is just generally searchable. But private repositories, and you'll see it down here, the private repository option allows you to work on projects that are maybe not ready. You don't want to show them yet as part of a portfolio, or maybe they contain information that you can't make public. And so there is the option to work on repositories in GitHub that no one else can see. And this makes it nice because you can't, on the free tier of GitHub, you can't work with more than 3 external collaborators. But with those collaborators, or if you pay for the paid service, you can have collaborators working on the private repository without it necessarily being something that anyone can search. And so that's just to understand that when we're talking about the repositories on GitHub, there is a public and a private tag. When you're working on your own local machine, obviously I can't see that unless you put it somewhere that's public online that I can find. So my private repo on my computer that has no remote cloud repository is obviously private. So if you're following along, let's take a look quickly at GitHub now. So if you if you're following in the slides, you can click on the link. It should open inside NAC. I will just switch to the one I already have open here. And it will bring you to, I'll just show you the URL. Essentially, it'll just bring you to the username/repo URL of this repo that we've chosen here as a demonstration. So I'm going to give everyone a second to just open that. Maybe you weren't following along the slides, but please shout if you're having a problem, because it's useful just to actually get to click around inside the repo. Remember, you can't break anything here. So looking around is totally safe. Are there any issues? That's good. All right, so what we're doing here is you're looking at the landing page of any repository, including your own. So if this was my repository, this is what it would look like. You see a whole bunch of information. You can see that it's public. The repo is public. You can see a selection of tab set panels here that you can go and find different components of information in. They match some of the terms we talked about. The code is just sort of the file system, the general file system. And if you look around, you can see it looks like a file system. So you have some files in the root, and you have other documents like, I'm assuming you open a few of these, and you've got other information contained in more folders, etc., etc. And so it works like a file system here. The branches, if you look around here, where you see the word main and you see this little icon, you're looking at branches, and you can see all the branches that are currently open on this project. So you can see here that, we have a main branch. This will be the one that's kind of the most stable version of the project. The development version, other sort of specific issues or feature versions which are being worked on. And I think some of these, if we look at them, are actually stale. So in other words, like a branch that hasn't been worked on for a long time will actually be listed as stale. In other words, there's no active development going on that branch right now. So for instance, you can see here the stale branches, like this one was last updated 5 years ago. So the more recent development has happened 17 days ago, and you can see who even contributed to that branch. So maybe just click around. I'm not going to direct your attention. You can just get familiar with GitHub if you've never looked at it before. But just click around for a minute or two and look at all the different sort of tabs and options you have. Ask me any questions if anything comes up that doesn't make sense. And I'm going to give you a minute or two to do that. All right, so we'll get some more chance to play around in GitHub as we continue. I hope you Well, let me ask, are there any questions about what you're seeing here that doesn't make sense? Anything you want to ask? I mean, this is essentially a dashboard, if you think of it that way, of information. So there's a lot to go through, and you can spend a lot of time playing around looking at specific commits and when commits happen, etc., etc. But let's continue so we can get to the fun part of playing around with it. Also, if you weren't logged into GitHub, particularly if you worked inside Knack, for instance, you should notice there that you were able to view the repo even though you weren't logged in, because like I said, it's public, so it's searchable. It's basically like just a website. So let's get on to setting up, and we'll make sure that as we get through the setup, we can, if there's any issues that we need to take some time to fix, we'll just do that. But if you haven't already done so, or maybe you don't have one yet, you can click on the link to create a free GitHub account, and they are free. There are paid options, but you can create a free GitHub account with just your email address and a password. And if you haven't done that and you're doing it for the first time, just some general tips. Incorporate your actual name if you want to use it for any sort of professional things. It's just people may know you by your name, not sort of a nickname that people have for you, which makes it easier to find you. It's not impossible to find you if you use some kind of a nickname as your handle, but it is easier to find you if it's part of your name. Shorter is generally better because you'll probably be typing your own handle quite a lot. So that does help you to have a shorter handle. And also, if you're going to use GitHub, in your career / throughout the rest of your life, you should probably choose a username that you'll enjoy for the rest of your life. And maybe even that you're comfortable revealing publicly. So those are just some tips on usernames. And if anyone doesn't have a GitHub account set up, just please let us know when we get to the point where we're starting to work on things. And if there's any issues setting it up, there is information in the docs folders to help you, and we can help you too. All right, so before we take a little break, I just want to sort of get us all set up inside Knack, because Knack obviously is a virtual machine. It doesn't always exist. And so what's nice about Knack is when we spin it up, it doesn't actually have anything set up for us. So we get to do it all ourselves. So if we now look at Knack here, I'm going to ask you to open a terminal. So open the terminal application, this one here. And if you're following along on the slides, I will just scroll through. All right, and here we are. So the Git Config command is obviously, as the name suggests, the one that we want to use to set up Git. And it will manage how Git gets used either within a project or just generally on your system. So the way that you, in this case, inside your user space, if you were to type git config and you were to use the list flag, so the -l argument, you'll see nothing because it doesn't have any configuration set up for you. So what we're going to do now is, and you can do this with me, is you can type in git config, and you use the double hyphen to add the global flag. So we're telling it that this must be the case for the system, for our entire system in terms of our user. We now are going to then specify which part of the config file we want to name. And we're going to say that we want our username to be our name. I will just call myself Gavin. You can call yourself your name and surname. And when you hit enter, you don't get any immediate feedback on this, but you also don't see any errors. So let's assume everything's fine, and let's do the next command as well. So let's set up our email address using the same git config global flag. And now we're going to specify that what we want to set is our user email. And I'm just going to set it as my work email address. And good. And now what you might want to do is you might want to check that that worked. So now we will test again. We can use the -l flag. And what you'll see has happened is Git now has a key value pair for me. It says your username is Gavin, your email is gavin@fathomdata.dev. And as you see in the slide, this is important because when we make commits, it's not always Gavin working on the project. Sometimes it's Andrew, You know, sometimes it's another colleague, sometimes it's me, and who makes the commit gets stored when you make commit messages. So it's important that we set this up for ourselves properly before we do any work on a project. That way, if anyone has any queries, they know who to ask, email, or even blame. Git blame is a feature of Git as well, but we won't cover that today. So let me jump back quickly. As we progress here, we are going to be working in a Linux environment. And if you've never used Linux, or maybe you have used Linux, I'm just going to remind everybody of the basic commands that we will use in this tutorial. There's the cd or change directory command that we will use to move between subfolders and folders. ls is essentially to list the contents of a directory. mkdir, so make directory, is the way that you would create an empty directory. Cat, or essentially think of it as a print statement. If you use cat and then a file name, it will print the contents of the file for you if it can. Echo is the same kind of idea. It's a print function as well. Touch is something that you can use to either create a file or to just to change the date the file was last modified. And the man command is essentially short for manual. So if you use man and then git, it will give you the git manual. Or if you use man and git and then dash and a function, it will give you the manual for that function. So these are commands that they're listed in the documents HTML if you want to just keep them open there, and we'll be using them. If you've never used this before, it's useful to know this level of commands, because even if you work in Git on Windows, it installs Git Bash, and Git Bash actually works with these commands. It doesn't use Windows PowerShell commands. So it's useful to know these. All right, so let's jump into a little bit more of setup. If we just scroll down here. All right. So if you're following along on the slides, what we're going to do now is, for each of us, we need to create the folder that we're going to use for our toy project today. So we're going to change to our desktop, and we're going to make a new folder using the make directory command, and we're just going to name it version control. You can name it anything you want if you want to do that. You can name it git intro, use R, anything you want, and it will appear. When you do that, you can now see I have a version control folder up here. We now need to move our focus into that folder. So we use the change directory command, and we can then go version control. And once we are inside, if you want to look at what's inside, surprisingly, there's nothing. All right. So we're looking at an empty folder we just created. And now what we do is we turn it into a Git repository. And the git init command creates the setup, or it does an automatic setup of the folder that creates what it needs to run Git inside it. So now when we run our same command, and you can shortcut commands if you make typos or anything else by pushing the up arrow. So up and down arrow navigates through your history. So when I run the same command and I want to list everything, we now see that we've got this .git folder. The .git folder is essentially your Git repository. It stores all the information that's important. So if we talk about that just for a second, the Git folder will grow over time as your project does, and it will grow to meet the needs of how you're using Git. So depending on what you're doing with Git and how many commits or how big the project is and everything else, it will look different. But generally speaking, when you are working in a Git repository, you'll always have the .git folder in there. So if we change into that folder, and we can target it with the .git command, so change directory to .git, we look inside there, we will see that it has now been populated with different objects. Some of them are files, some of them are directories. It doesn't really matter for now. If you want to get more familiar over time with this, you can start to look inside each of the directories and read the files as you want to. But let's just move back into our main project directory by using the cd, so change directory, and the .. matches to this over here. And all that's doing is it's moving us one folder back up in the tree. So it's moving us from this folder to that folder. And now we are back in our main folder. I am going to be clearing the sort of terminal quite a lot to keep it from always being at the bottom. And to do that, I just push Control-L. It makes it a bit easier. And now what we're going to do is we're going to create a file. So I'm going to use that touch command I mentioned, and I'm just going to call it data.csv. And now when you look at, when you list the files, you'll see there's a new file in there. And what we can do is we can also now look at how Git is behaving in the presence of the new file. So we can now run this command, which is very important to know, Git Status. And Git Status tells us a whole bunch of information. It tells us the branch we are on. It tells us whether there are any commits on this branch. It tells us if there are untracked files. In other words, it can see files, but we haven't asked Git to version control those files yet. And then it tells you, it gives you these helpful messages as well for what to do about the situation that you see. So in different contexts, these messages change, but here it tells us to git add file, and it then will be included in the next git commit that we make. So I'm just going to switch to the bigger version of this for everyone to be able to see it a bit easier. But let's talk about what it suggests there. We've created a file in our working directory. But the file itself will not be tracked by Git unless we tell it to track it. So we need to say to Git, you need to add this file to the list of files you're tracking. And that Git Add command is exactly the way you'd expect it to work. And it takes things from our working directory and it stages them. So there's this, before things are actually inside the Git folder, there's a staging area. And that's kind of like the preparation room where you get to sort of set things up the way you like it, and then eventually you get to tell Git, that's the way I like it. And the staging area is interacted with the Git Add command. So if we go back into our terminal now and we follow the advice, if we run the Git Add command, I'll just do this so you can see it there, but if we run Git Add and we specify the exact file, so we name the file, then we can add it. And now when we run Git Status, what you will see is that instead of this red data.csv, you now see a new file, which is a change that can be committed. All right. So now this is telling us that Git has staged the file, and it will, from this point forward, it will start tracking this file. All right. So we've now staged the file, but what is a commit then? Well, a commit is essentially, it takes the files in the staging area and it attaches a commit ID, which is a hash, and it attaches a message to that action of then adding the files in that state to your local Git folder. So that's .git folder. It will be updated once we commit. And what you'll do is you'll be automatically, it'll generate a hash for you, which is unique. And it will take the message that you supply and it will permanently attach that to the commit. And I say permanently in inverted commas because there are ways that you can modify history, but it's generally something you should only do when you're very confident you know what you're doing, because modifying history can break things. And one of the reasons we're using a version control system is obviously not to break things. So the commit is essentially like Git takes a photograph, imagine it being like that still frame of everything as it is at that moment in time, and it stores it in the .git folder. It does it automatically for you. You don't have to manually do all that stuff. But what you do is you use the Git Commit command, and there's two ways you can do this. I'm going to show you, first I'm going to show you how you can do it in just the command line. But oh no, then it'll actually be finished. So let me do it in two ways. If I just run git commit, and you can test this. If I just run git commit, what actually opens is your default text editor. And what it does is it includes inside the text editor the information about what's happening in this commit. But the message that you need to add would be like initial commit of the file. And when you then exit, so for instance, this is VI, so we need to then do a quit, and I'm not going to save this. But you would save the message that way. The way we're going to do it is we're actually going to do it just from the command line because we're writing a short git commit message. So we are actually going to use the message flag. So we are going to say git commit -m for message. And then we simply specify that we are adding the data.csv file. You could do anything here. This is, again, just a toy example. There are definitely best practices around these things. But the key is that now Git has actually taken action. So it says here that it has created a commit, tells you some of the information about it. It tells you how many files were changed. It tells you the mode of the file, which is, there are codes that you can understand if you need to about what the file is or other information about it. And now, when we go back to our Git status, you'll see that there is nothing to say, because what Git is saying is, we're all good. I know the most recent version of the project is in the .git folder. So we now have a new command that we can look at, which is the Git Log. And this command is really important, and we'll discuss it more. But essentially, this now shows us that we have created, at this date and time, we have created a commit with the message that says add the data.csv file. So you should see here that you have a unique hash. It won't be the same as mine, I'm guessing, unless they really do start with the same one. But maybe you can confirm that for me, that you have the same or a unique hash. But the point is, this is the ID that Git logs that specific version of the project against. And the metadata here is, obviously, if you have a question about why I added this file, you know who to email, like we set up. Okay. An important thing to note here is that any files that we don't put in the staging area, right, will be essentially assumed to be in an unchanged state for that commit. So we may have modified them, but because we didn't stage them, Git will not include them in the commit. And that's an important distinction, which is why you have the working tree, the staging area, and the final local repository, that .git folder. Are there any questions? Did everyone manage to make a successful commit? Good show. You'll get pros already. And so now, let's discuss what we did with the Git message. So the commit message is essentially the version of you that knows what's going on, talking to your collaborators or to your future self. So a commit message is not some sort of abstract thing that we're doing here. It's a really important component of your Git repository. A commit message should be human readable, and that sounds like a silly thing to say, but you're communicating with a human, right? The Git is doing the stuff that talks to the computers. You need to talk to the human who's going to be looking at the project and saying, why did Gavin make this change? And you're going to essentially spend energy explaining why something happens. Because if you're making a change, there's usually a reason, particularly on long-running projects. You're going to make changes that you have a reason for, and the Git commit message is where someone will look for that reason. You don't have to explain what you did. That gets stored in the differences between the files, but you do need to explain maybe why you made the change. Because if it's not immediately apparent from the code or whatever else you're working with, then you need to think kindly of your future self and help you out when you're confused later on looking back at this. And ideally, you should be clear and concise, because on a long-running project, you don't want to write essays for every commit. That'll both take you forever, and it'll take forever for someone else to sort of sift through all the information. So there's a happy middle ground. You want to give enough information, but you don't also want to, write an essay. So the little cartoon on the side there is just a sort of example of the kind of tension that you have. You can't just say things like small changes, but you also don't want to write the entire existential, thought process that you go through when you're committing. All right. So just to keep giving you some ideas on this, and it's something that I'm still getting better at doing. So I must say, like, even as I use Git, I'm still improving the way I write messages. But good commit messages essentially help the person in the future track how things have evolved. And that's the way you want sort of to think about it. A commit message that helps people understand the way that we've arrived at the stage we're at, or the reason we changed from the path we were on, is very important. and it's often the key to effective debugging. If you write yourself messages on the right here, like typo, more changes, you know, when you're looking at your Git log, you're really going to have no idea what's going on if you're looking at these messages. So you want to be really thinking of your future self and collaborators. You can use messages that essentially describe things like adding files, creating something within the repo, fixing a bug. Maybe there's a new release that you need to document and tag. If there's a document itself or you're doing document actions, you can use that kind of a flag. All these are good things to basically explain in your Git commit messages. And as I said, the most important collaborator you'll probably find is that you want to be kind to future you. Yes, Andrew.
Gavin, just to interject, there seems to be a little bit of uncertainty about the difference between add and commit. So it may be worthwhile just spending a moment or two talking about the staging area and why there's a staging area.
Yes, let's do that. Thank you. All right, so I'm glad you asked that, because to think of what you're doing when you are working in your project, the mental model you have is very important. And Git doesn't want to be too eager to just sort of take any changes you make and assume that that's the version that you now put in the permanent, and I say permanent, record of the project history. So what you're doing when you're staging a file is you are essentially saying, maybe it's a new file or maybe it's a modified file. And you're telling Git, yes, I'm getting to the point where I like the way that this file is now set. So maybe I've changed my code, I've tested it, it works. And I want to place it in the staging area. In other words, I'm done with modifying this one, but maybe I'm not yet ready to commit because I'm going to add one or two other files that have been modified so that this file works. And I'm going to place all of those files in the same staging area. The process whereby you do that is the Git Add Command. And the Git Add Command is like we saw, like we saw in the situation here, is that when you have a file that's not being tracked, the only way that Git will ever start to track that file is if you run the Git Add command. If you don't run Git Add, what you do is this will just sit here untracked. So any changes you make or anything you revert or anything you do, Git will not be able to help you on this file until you have staged it and told Git to track the file. And that's what happens the first time. But after that, so now let's do a small example, and we'll get to this later, but you'll see it again. So let's just echo a thing where we say my awesome data. And we're going to append this double greater than sign is essentially going to append that line of text inside my data. My awesome data is going to go into the data.csv file. And what that does, if you remember, up here, it says there's nothing to commit because the working tree is clean. But now, when I run Git Status, I will see that this new flag here says modified. Now, this is a file that it's tracking, so it tells me it's modified because it knows what the previous version of my data.csv file was. It's not an untracked file, but now it's modified because it's changed from the version that existed when this commit happened. And here again, to just go back to this idea, if I think that I'm happy because my awesome data is all I want to add to this file, then what I'm going to do is I'm going to say, yes, Git, I'm happy with this. And now I will git add, right, that same file again. I can name it individually, or I can use a shorthand, which we'll show you later. But if I'm specifically happy with just this file, out of all the untracked or modified files, I add it to the staging area. And now you'll see Git happier. You'll see the green that says, okay, good. We're getting closer to actually making a commit of this because it says that this change can now be committed, right? Before that, it was telling us these changes are not staged for a commit. But I've told Git this version of the file, I'm happy to commit that version. And then I would run my Git commit. You just do that here, and I will say new and improved data. You can do it any way you want. I'll just do this. And the commit message will now, I'm not specifying the file exactly, but I'm just committing everything that's in the staging area. And what the Git commit is essentially doing is it's taking it from here, and it's now going to generate a unique hash for the file state, right? So now this modified file state will now be committed. And so when I do this, you'll see it now says it's been updated, and I get a different hash here. And then when you look at the Git log, you can see that I now have two commits. I have the previous version, the first version of the file, and I have my second commit, which you can see came after it, 10 minutes afterwards. I had added some data to it. So I hope it gets easier with using it, but it is definitely a part of the mental model to get used to. Yes, Andrew.
Yeah, I mean, just to add to that, the way I think about the staging area is it's a way for you to basically manicure your commits, and that is like you want to. It really comes into its own when you're working with multiple files. So supposing you make some edits on file A, you think it's done, so you add it to the staging area. You then go make some changes to file B, add that to the staging area, but then you realize, oh, hold on, I need to go make additional changes to file A. You go back, change file A, add it once again to the staging area, and once you're happy with the state of file A and file B, and they're both in the staging area, you then commit them together. You know, I think when I started using Git, I was just shove everything into the repository. But the more I've worked with the tool, I've realized that it's worthwhile sort of thinking carefully about the state of your files and which files you commit together. So I think quite carefully now about adding things to the staging area until I'm quite happy that I have everything in a consistent state, and then I commit the staging area to the repository.
Exactly. Can't agree more. Because we'll discuss what the log does for us, like the more attention you pay to your commits, your messages, etc., and the way that you like group files in the commits, the more powerful all of these Git features become. So let me just skip forward. We got to commit messages, and we looked here. This is just a little thing I came across online. I heard someone more experienced than me talking about it, and so I don't claim credit for any of this, but the idea of committing is that you can commit often because your repo needs to tell you what's changing that's important. So sometimes you're making just a few changes to one file, but they're important changes. You just commit the single file, and that's a commit on its own. You don't have to lump that file with another 7 files that have different commits for different reasons. You can commit as many times as you want. The only thing that you should sort of think about is, perhaps if you're sort of working with colleagues, is you should think about when it's appropriate to push to a remote. Like, you wouldn't want to just be committing and pushing every single time you're working on a collaboration, because that creates a situation where your colleagues are always perhaps needing to update their repo all the time. So you have a situation where if you think about committing as something you can do whenever any file is ready, like Andrew said, then you'll actually have a much nicer Git log at the end of the process. The log will tell you a lot about each specific file, and there are versions of the log command that can actually find specific types of file changes or track one file through all of the changes that are relevant. So it's an important thing to think about how you commit, and it's, as Andrew says, it's an experience thing. You'll get more experienced over time. All right, let me just jump ahead. How are we all doing? I just want to check in. Do we want to take a break here? Anyone need a comfort break? I'm not sure why I can't see a show of hands per se, but maybe Andrew, you can tell me if there's any. How are we feeling? Do you want to push on?
I personally would appreciate a couple of minutes just to go and grab a cup of tea.
Yeah, I think this is a good place to do this. I think we've seen Git in action. Maybe if you want to carry on playing around for 5 minutes, let's take a 5-minute break, and then we'll come back and we'll start getting into some of the hands-on, doing some more getting our hands dirty.
You didn't.
give everyone a few more minutes. But if there's any questions, I am here if you want to ask me anything we've covered so far, or maybe something you know but don't understand about Git. We can take a small tangent if anyone has any questions. Maybe in the chat, if you can, just sort of mention if you had experience with Git before, or if this is your first time ever looking at the Git version control system. I'm just interested to know. We all start as beginners at some point, and Git itself is fairly recent. So I know many experienced programmers, like Andrew himself said, that we're all still learning Git. So please don't be shy. You can just say, I'm new to this. Every day I read more of the documentation. I still feel like I'm new to this. So please don't be shy if you want to just share that you have no idea what's going on. But I am interested to know what sort of user levels we've got in the class.
Cheers, go.
Excellent. All right, it's been about 5-6 minutes, and I do want to push on to give us more time to play around with the actual Git command. So what I'm going to do now is I'm going to spend some time just talking about what we're looking at here in the terminal, the Git log. And the more I use Git, the more I come to appreciate that Git log is one of the commands that has the most important implications for how I can collaborate on someone else's project, as well as also contribute to my own projects and collaborations. If you think about what you're doing as trying to create a nice log file of everything that's going on in the project, it really gives you some like sort of sense of gravitas, that like a really nice setup in terms of working well within Git creates a situation where it's much easier to do the things that Git really helps you do. For instance, the Git log command is a way that we can travel through time. So if you think about it now, we have a small project with 2 commits in my case, if you didn't do the second commit that I did. But I have 2 commits, so it's pretty easy to see the evolution of the project. But over time, it gets much larger, and there's different changes and ideas. Files appear, files disappear. All these things go on, and the Git log command is how you're going to navigate through that as needed. In some cases, you'll only need the most recent changes, but in other cases, you may need to go far back to find the reason for something that happened. And the more carefully we manage the commits and the commit messages, the more powerful the Git log becomes. So, you know, it becomes easier to search, for instance, if you use commit messages in a structured way. You can search commit messages, for instance, etc., etc. So we're not going to cover all of that stuff now, but I have included a link to a book chapter on Git that will get you started if you're interested in understanding the context in which our work and our version control diligence creates a situation that makes it easy for us to go back and check what happened when. And so like I said, I'm still getting more and more appreciative of this fact as I work with Git. So let's look at the versions of the command that we will use in different ways, or that you might encounter. If you want to see just every commit, you'll just use the default Git log, and it will print out everything. So in my case, in NAC, you're basically looking at the log file in its entirety. But if I had 200 commits, you would see a paginated version where it would sort of ask me to press the space bar so I could see more commits. And in long-running projects, that's definitely the case. So it's not always the most helpful to just use the default. Maybe you just want to see the most recent commits, perhaps in the last 3 commits that you've made on your local repository. You kind of think, oh, I need to fix something, or I just want to check that file and make sure that it's the way I want it to be. When you put the hyphen or the minus sign and then a number, it will show you that exact number of commits. So it'll show you the most recent commits up to that number. So for my situation here, if I were to do git log -1, I only get the most recent commit of my new and improved data, and I don't see the original commit. The pretty version, so the log can be quite sort of verbose and hit you with a lot of information. The sort of prettified version of the command, if you run git log and then you use the -- one line sort of shorthand, it will print a pretty version of the log file for you. So git log. Essentially here, it shortens the commit hash. So, it's not the entire thing. It gives you the relevant information about what's happening where. But if, for instance, if you have a longer git message, it won't show the entire message. It'll just show the sort of heading on the message. And that's, this is the, like if you're looking at a lot of commits, but you're not sure which one you want to, this can be a nice way to get a summary. You can filter by date. So let's say that you want to look at the project. Maybe it was an app you're working on, and that you made changes in a certain period of time. You want to look at all commits maybe before the date that the changes happened. You can specify that. The date would be specified inside a string. There are different ways you can specify the date. For instance, like April 1st, 2012. Those kinds of things. You can even filter the commits to be between a date range. So you can specify that you want them between a certain date and up until another date, if it's not the present, etc., etc. You can view the summary of the changes that are made. So I can show you that myself here. We can just go git log stat, and you'll see that it essentially shows you the kind of stuff it told you at the time. It just shows you what got modified, and it shows you that in this file, we had one line inserted. So it's saying in the data.csv file, from this commit, one file was changed and one line was inserted. And that's why you see a plus. If lines were deleted, you'd see a minus. And if you want to see very detailed information, the log-p. So for instance, let's say you're even looking at a specific commit, but you want to see it. This will show you exactly what happened. So you'll see here the initial commit simply creates the file. It just says new file, and it creates the sort of index for it. And then here it tells you that I added this line. So I added the one line to it. So between the A version of the file and the B version of the file, there was this addition, and the addition was that I added this line. And that's the sort of more verbose version. All right, so there's a lot you can do there. And now we're going to get to the point where instead of me showing you how it all works, I'd like to sort of give you a chance to do it yourself. So if you follow through, or if you've got the exercises open here, and you just see that you can do all the basics here. I'll give you a few minutes to do this, maybe 5 minutes. Just create a file that's new. You can use Git Status as many times as you want to, for instance, to check it out. But just see that you can get everything of 1, 2, and 3 back in the terminal. If you're confused about this command, let me just show you the big version. This is essentially, I'm printing what's inside the quotation marks, and this single greater than sign simply creates the notes.txt file with this string inside it. That's all we're doing here. We're saying we want to put this quote inside this file. And if it doesn't exist, it gets created. And if it does exist, it gets overwritten.
Gavin.
Yes.
How about telling us a little bit more about the significance of the access token?
The access token. Yes, I'm glad you asked. We will get to the access token soon, and we will discuss the pros and cons of why GitHub has actually moved away from using a username and password to using access tokens. I think their reasons are well justified, but the short version is you can have many access tokens against a single user, but you can only have one password. And so essentially that does create a situation where sometimes I myself don't want to have all the privileges inside my own GitHub account. And what that means is that maybe I don't want to modify or be able to delete or like change a repo. I just want to be able to access the contents of a repo and access those inside an app that I'm running. And because I'm not monitoring the app, I don't want the app to accidentally execute code that nukes the repo. And an access token is a nice way to control the fact that the app will use the access token with limited permissions to access my repository. But when I want to go in as the editor and the maintainer, I can use a different access token, which gives me read-write permissions. And I think that's quite an important distinction, is that before, you were kind of always logging in as your user and password, and you just had all the permissions.
Strategic sourcing manager, because that is gone.
All right. All right, I'm going to assume that everyone's managed to do this now. And if you haven't, I'm going to do the walkthrough and show you how it works, so you can see it play out. Oh, I see a question. Yes, is it quarantine?
Yes. Can you hear me well? Or
I can,
okay.
Yes.
Is that possible to commit specific files, or will the commit will commit all the files in the staging area? I mean, if I have 2 files in the staging area and I want to commit only one, is that possible to do that?
Yeah. In many cases, we're going to show you the most general versions of a command. But if you're ever interested in seeing more about how things work, you can see here that you have different options that allow you to specify with great control. Because remember, the point of this is that if you want to use Git at a very advanced level, Git is making it possible for you to do that. So general use case, you're going to use it at like a level that's kind of like add, commit, do things manually, control it a bit yourself. But let's say for whatever reason, you do need these very fine-grained controls. I'm not going to overwhelm you with all the information in these pages, but if you look at them, they will explain all these kinds of things. And you've got pages and pages and pages of explanation of how things work here. It'll explain to you why they've built it the way they have. It'll explain to you all these different options you have, how it interacts with different settings. It's extensively documented. And the short answer is yes, you can commit exactly a specific file from your staging area.
Okay. Thank you.
Great question. Thank you. If you did open the help file, by the way, sorry, let me just say, if you did open the help file, just push the Q button to exit that page. Yes, Andrew.
Yeah, I'm just going to say that, I mean, in general, your commit is going to take everything in the staging area and push it into the repository. If you're wanting to do individual files and there are multiple files in your staging area, then I would say just follow the instructions, remove the one, and just commit the one that remains.
Yeah, it's sometimes simpler not to ask ourselves to do the advanced commands, even though we can. All right, so I'm going to quickly step through this. I'm creating my notes file. If I look at what's inside my notes file, I'm going to use cat. Remember, that's the function I mentioned that basically prints. So all you see here is it prints out my important notes, because that's all I put in there. And if I look at the Git status, I see that it is untracked. So it tells me it's an untracked file. And if I want to add it, I can use git add and I can name the file, or I'm going to show you the shorthand. If you just put a dot, it will take any untracked file. So any untracked file, which is why you have to be careful with the shorthand. For instance, maybe there's a file you don't want to be tracked. You don't want to use the dot, you want to name it. But if you're okay with that, git add dot will simply have done the same as git add notes.txt. And then when I look at my git status again, I should just be using up arrow to show you that it's more efficient that way. And then you see now it is ready to be committed. and I can run my git commit. And what I'm going to do is I'm actually going to do it this time from my default editor, and I'm going to say feature. So I'm going to say, here's my new file, my notes file, and I'll make it actually a bit more best practice by saying adding my notes file, and essentially once I just go esc and I write it, if you know Vim, there's a bit of a thing there, but essentially I've created my message. And when I look at the Git log, I will now see that the most recent commit is there. So hopefully that was successful for all of you. You don't have to follow everything to the letter when you do these things. The principle is mostly that we're giving you the way to sort of think about doing it. And I hope that was very straightforward. So now we're going to move quickly through some of the sort of ideas of what Git's doing to track things for you. So with that notes file we just created, and you've seen this once before with the data.csv file, if you want to know what's going on inside the file, let's say maybe you've forgotten what was changed because you were working on a file, then you worked on another file, and now you're not sure if you should stage this file, the original file that you're working on. When you come back to the file, if you look at the Git status and you see that it's modified, so let's do another echo command. I'm going to scroll up to my echo, and I'm going to just change this. And I'm going to say I want to add my next important note. And I'm going to make sure I modify this greater than sign to make it 2, so that it appends to the file and doesn't just overwrite it with a new file. That's the only trick there. And when I run that, essentially now Git status will tell me, aha, modified. Now let's say I don't remember what I modified there. If I don't remember, that's where Git Diff will help me out. Again, the default option for Git Diff is to tell you the differences in every file that Git is aware of having been modified. So if I don't specify the file name, it will just tell me the differences between the states that it has in the commit history and the state that is in my working tree. And so here what you see is the white, my important notes, is shown as being part of the file, but the difference is listed here as this green addition. And it simply is my next important note. So it shows you that the difference between A and B is that there's this extra line. All right. And so you can use diff in many different ways. You can even have the diff be presented in another UI, so a user interface that gives you a nicer, prettier printout. For instance, in VS Code, there's a very good diff feature between your working tree and what's in the commit history, et cetera, et cetera. So different programs do it different ways, but the essential part is that at the command line, you can still see the difference. Obviously, if there's 600 lines that are different, this probably gets a bit overwhelming. So it's a thing you need to know about, but we're not going to spend too much time looking at it specifically here. And the diff is essentially what gets committed. Like that is essentially what gets snapshots as being like, this is what changed between this commit and that commit. So now let's talk about how we're going to integrate some GitHub into this whole workflow. Because so far, all we've done is we've worked on our local knack user instance. So inside our .git folder in our local file folder, we have all our commit history. But if you were to look online, it wouldn't be there because we haven't managed to set up a remote repository for this project. So what we're going to do now is we're going to set ourselves up to push our commit history to a remote repository. All right, so if you have a GitHub account, and maybe we need to just do a check here, Andrew, can you monitor this? Oh, I see a question. With the diff, why does Git show me the diffs I haven't put into the staging area? Okay, that's a good question. The idea about the diff is that it's showing you what's different in the file so that you can sometimes make the decision if you want to stage it yet, or maybe it's not ready. For instance, maybe you can see in the diff that you've got comments saying, need to fix this code, and that's literally the only difference. You don't want to commit it with the comment, you want to actually fix the code and then add it to the staging area, if that makes sense. So the diff is simply showing you what's changing. All right. So is there anyone who doesn't have a GitHub account that they can sign into? All right. I'm going to proceed as though we all do. But what I'm going to do here is, if you're in your GitHub account, so you can see this is me, philosophical younger me, staring off into the sunset, and I am now inside my repositories tab, and I'm going to create a new repository for myself. And what you get is you get this sort of general template for filling it all in, and you can essentially, we don't need to worry about that, thank you. Apparently we do need to worry about that, but basically the repository name that we're going to do here is something like version control, and Git actually, your GitHub account will check if you have another repo with this name. So you can see here, this name is available for me to use, and I can now add a description if I want to. I get to choose options, and we're going to make it public. And I essentially am going to, I have given it the same name as my project, but you don't have to. And what I'll do now is I'm just going to scroll to the bottom, and you'll see at the very bottom here, the green button appears that says create repository. I will now do that. And what you'll see next is you'll see some helpful information. So the information contained here is essentially information that's going to help you both run Git commands. So it shows you a bit of how to do stuff to set things up, as well as it gives you the actual URL to the repository on the remote. So in other words, this is the URL of my version control repository on Git and GitHub specifically. And one other thing to mention here is that there is an SSH and an HTTPS flag here. We will look at both of these, but essentially the URL changes slightly based on the way that you want to access this repository. So depending on what you want to do, you will use either SSH or the personal access token. So what we're going to do now is we're going to link the local project folder on our NAC instance to that URL. So we essentially are going to copy, you see, we're going to copy that URL. There it is set up for us, just like you should be seeing it here. You can either click that button or you can copy it the way you know. And this is where I told you we now have to do a little bit of copy paste shenanigans to get it into NAC. So I copied this from my Windows browser. To get it into NAC, I just have to make sure that I open up this little side panel that says no VNC, and I have to make sure that I paste it into the clipboard here. And once you can see it there, don't push the clear button. You can just click this if you're blocking anything important. But as long as it's visible in the clipboard there, it is the thing that you can now paste. So I'm going to clear the terminal again. And essentially, you'll see here that what we're going to do is we're going to use the command of git remote add. And the way this works is we are going to add a remote, and the remote's name is going to be given as origin. This is sort of a standard practice. And then we add our remote repository URL. Okay, so that's where we paste the thing that we've got in our NAC clipboard. So we're going to go git remote add. You specify that we want this remote to be known as origin, because even though we started on our local machine, eventually we want the remote repository to be considered the source of the project. So we'll say that, and then we will paste. And on the terminal, you might have to right-click and paste to get it to do it. Control-V may not work. So once you've done this, you get no feedback, but you also get no error, which is good. And now what you can do is you can list the remotes that are there. And what you'll see here is that it's created two versions of the remote. It's created a version of the remote with a URL that you will fetch from. In other words, like the cloud sort of remote that you will pull information from, and the remote that you will push information to. And the only reason it's duplicated is because sometimes these are different. You can set it up to be different if you need it to be. But as long as that's working for you, that's good news. And now we're going to talk about pushing, because pushing is essentially like an upload. But what we're actually doing is we're not sort of sending every file in the sense of like a pure backup. We're not just overwriting the files per se. We're actually sending our .git folder and its commit history and the log and the objects that it remembers and has tracked. We're sending that to the remote repository. So we use the Git Push Command, and what we're going to do now is we're essentially going to tell the local repository that we want to send the files and commit history that we have locally to the upstream branch, and we're going to link the origin remote with the master branch that is in our local repository. And that is what we're doing there. So if you do that yourself, git push -u is a flag for the upstream. In other words, it's the cloud remote origin. It has to match. If you put something different here and there's no matching name of a remote, it will return an error. And now we get to the point where we have to authenticate ourselves, because obviously we can't just let anyone push to our remote. So now what we have to do is we have to authenticate ourselves, and we need to provide our username and password. So that is the username and password that you would use to sign in. And I have a slightly weird password. But here's the important part. The authentication, because I'm trying to use this authentication, it now sends a message to me, and it says that GitHub is of the strong opinion that passwords should no longer be used for authentication. And so what we've got to do now is we're going to have to set up a personal access token. And it tells me that my ability to authenticate using my username and password is not accepted. So the push that we want to do cannot complete because it won't authenticate my write access on the repo. All right. So we get to the point where we got the question earlier about our GitHub access token. So now that you're in your profile, we will navigate away from this page and we will go to our user up at the top right. You see I'm signed in as the user, and you go to your settings. I'm going to go slowly so you can follow. Go to our settings options, and you get a whole lot of options here, but essentially you've got to scroll down to this very sort of not necessarily logically and intuitively named developer settings. And under developer settings, you will see personal access tokens. And you can see here I have 2 personal access tokens already in use, and I'm getting warned that there's no expiration date on that. We'll discuss it. But for now, this is the button you're looking for here, generate new token. I have to authenticate myself now with my password because I haven't done an action that required GitHub to check that I am who I say I am and that I didn't just leave my computer open. Now that I've entered my password, I can now begin creating a personal access token. Is everyone with me? Because this is a new component of GitHub, and I don't want anyone to get lost in this process. All right. The note that we have here, basically for this note, you just want it to be something that is informative. So I'm just going to call it PAT for NAC. That's very informative. It tells me that I'm only going to use this personal access token if I'm accessing my GitHub from NAC. I'm going to leave the expiration date as 30 days, but you can specify that, so you can modify it as you want. And for now, I'm going to simply select repo. And repo gives you the full control of private repositories, and it allows you to do a whole bunch of read and write stuff, which is what we need. All right. I'm not going to click any of the others because if you've selected repo, you've actually selected, all the permissions, so you don't have to select all of these. And now this is an important step. When you say create new token, this warning message pops up because while you can see my access token here, I can't see yours, and you will never be able to see this again. So you really don't want this to be available publicly for someone else to access. Because with your username and this code, someone could hack your GitHub. Okay, so you copy this, and essentially what I'm going to do is I'm just going to store this in a text file on my second screen. And that's just for the session. But you should store it somewhere that you know what your PAT is. So you should also have some kind of thing that just tells you if you forget. Maybe you have a password manager, or maybe you have something else. But essentially, you just need to store the personal access token somewhere that you can retrieve it. Because now, if you see this, if I go and I say, move off this page, and I come back and look again, well, I can look at the personal access token, I can see what it does, but there's no way it's ever going to tell me again what that actual personal access token is. All right. And don't be too stressed if you lose one, just delete it, start a new one, just move on with your life. But it makes for a bit of a hassle if you have to keep doing this every time you want to push something to your GitHub. So now let's go back to where we were. We've created everything as we need to. And what we're going to do now is we're going to go back to that Git Push command. So I'm going to push the up arrow. And I'm going to now use my username the way I did. So that's just my, oops, why are we not typing? Hello? Do you not like me? Okay, you are responding. Let me run that again. There we go. I will use my username. And now instead of the password where I log in like through the web portal, I'm going to use my personal access token instead. That now serves as my password. And because remember, this is outside of NAC, I'm going to copy it in my Windows and I'm going to place it here. And we'll just delete everything. And now that it's visible there, I will simply close this and I will paste and I will hit enter. And voila, I get no more warning errors and I have authenticated myself on the remote repository with read-write access. And now I can push the contents of my local repository to that remote. And if you just read it, well, let me give you a second to make sure everyone gets that. Please, everyone, tell me that if there's any problems, please let me know. All right, I see a few problems. Let's do another personal token. All right, so if I go back to my sort of general sort of landing page and I go to me, well, I should actually just, or I can, oopsie. If I'm on my profile page, right, the way you want to access your personal access token options is to go to the top right and you go to settings. This is all distraction. You can set up your bio and a few other things, and that's great. But what we want is all the way at the bottom here, developer settings. And then it's the third option on developer settings, personal access token. And then you click on the generate new token, which offers you this page. And I'll say PAT for NAC duplicate. It tells me that I've got two that do this. You have to specify a permission, because if you give it no permissions, it will just be able to view public repositories, almost like a web search. But you have to give it the permissions of repo. And once you've done that, you can scroll all the way to the bottom and you click generate token. Is that helping everyone who's a bit lost? Excellent. Okay, I won't create the token. I don't need to. So I will just simply cancel. And I will go back to my profile. And now we can carry on. So hopefully you've seen this successful message. It tells you what it's done. It tells you it wrote 9 objects. And it tells you that it sent them to this remote. It tells you that I was working on the master branch and I sent the master commit history to the master commit history on the remote branch, etc., etc. And it also tells me that from now on, the master branch is set up to track from the remote branch on the origin. So in other words, if changes get made in the GitHub remote, I can pull those down to my master branch on my Git local repository. All right. So let's have an exercise now where, using your PAT, what I would like you to do is create a new file called script. You can do this with an echo or a touch command, however you want to do it. I want you to stage the file. I want you to commit the file to Git with a message, some descriptive message for yourself, and I want you to push it. So in other words, you'll commit it to your local repository, but now I also want you to send it to the remote repository after that. And I'll give you 5 minutes to do that. If you really get stuck, just shout, but I'm hoping that we've helped you enough to feel like these four steps are not too much. I see a question there that's asking, is it possible to get Git to save the username and the password? And the answer is yes, it is. There are different types of credential managers that you can use, but you can use a credential manager to authenticate yourself using your username and personal access token. And it can store different kinds of credentials as well. It's a bit outside the scope of what we're doing here today, but you absolutely can. And the other kind of authentication, which we are going to cover, is SSH, the secure shell connection. And that one doesn't require you, once you've set up your key to authenticate yourself between your machine and the remote, you don't ever type in a password. You just say push, and it checks if you are who it thinks you are, and it compares your key, your private key, to the public key, and then you can successfully read write. Andrew, anything else to add?
SSH is the way.
I agree. I think SSH is much more convenient.
It's a little bit of setup cost up front, but once you've got it, yeah, you won't regret.
All right, let's jump into the exercise. I'll pull it up on the side here so you can see what we're doing. Essentially, we're going to do something like echo hi, and I'm going to create the script. I could also just touch the script, but I'm going to create .r. It doesn't really matter what's in it, but my Git status now tells me there's a new file. You can see there. I've also still got my modified version of my notes file. This is good. And now I can show you that if I git add with a dot, both files will be added to my staging area. So now when I take Git status, I will see two files there. One is modified and one is a new file. My Git Commit Message. Hopefully this was straightforward. You can have done it with the text editor, or you can have done it with just typing in a message, and we'll say demonstrate, wow, demonstrate. Yeah, that's definitely not a great commit message. Okay, demonstrate, committing and pushing. That's what we're doing here. And there we go. Tells you what the message was. We now have a clean Git status. So now nothing will be, Git's not telling me I need to pay attention to any files. And now when I say Git push, I can actually just use the Git push command. It will prompt me again. Here we go. And I just got to check my clipboard. See, it's changed my clipboard. So that's why we store our PAT where we can retrieve it. And I bring it back in. And I will now simply paste. And voila. Hopefully that went as smoothly for you, because essentially the commands of staging, committing, pushing, and pulling are the majority of what you're going to do unless something goes wrong. All right, so now we're going to talk about the other way of working with changes. Imagine you've got changes that are on GitHub that Andrew has pushed to the remote, but Gavin doesn't have them, and I need to draw that commit history down into my local repository. Pulling is what I will do with that. So if we go back now and we look at what might have changed in our repositories. So if you're looking at your profile, you can go to your profile over here, or you can simply jump to your repositories. And you'll see here that I have my repository here, version control, and it is public. And if you're looking here, you will see essentially what's been happening. So you can see a little brief history. 2 minutes ago, I made this commit. It shows you which files are currently in there. And it gives me this prompt, just like you see in Amiro's demonstration of what she sees here. It gives you this prompt to help people interested in this repository understand your project by adding a README. A README is essentially like a, what is this project all about? So if we click on the Add README button, you'll see it gives you sort of like a title version of your project. And we'll just say learning Git and GitHub. And we will say, this is my repo for testing my new skills. Okay, you don't have to write anything. You can just simply say create. And now you'll see there's like no real obvious option as to what to do here. But if you scroll down, you'll see essentially that you get this option to commit. All right, and it gives you different options. It provides a default message. So in other words, if I don't supply one, it will just simply use create readme.md. I can add an extended description if I want to. And it allows me to either commit directly onto the master branch, or I can create a separate branch for this commit and start a pull request. And we'll talk about that later. But it's good to know that it's an option. And all I'm going to do is I'm going to say commit new file. And this will essentially, because I'm working inside my remote, I will essentially create the file, right? So now you see the last commit here is there. And so the create readme commit is now here in my remote. But if I go back to look inside my local, so if I list the files using my ls command, I don't see the readme here. All right, so before I move on, did anyone get stuck creating the readme? That's not the right window. Where's my window hiding? There it is. Did everyone manage to create the readme? Okay. I'll assume with no hands going up immediately, we are good. So now what I need to do is I need to pull. So I'm going to run the Git pull command. And what that's going to essentially do is it's going to pull from the tracked remote, or I could say Git pull origin, right? And I can specify other options. But if I run Git pull, what you'll see here is now does the reverse process. So it looks at the remote, it looks at what's there, it looks at what's different, and then it pulls in my new README file with the 3 lines. And if you've done the same as me, you'll see this happen. And now when I run my ls command, I now have my README file locally. Okay. And that's pulling. It's just about updating the Git objects either on your local or on the remote. Pushing is to send from your local to the remote. Pulling is to bring it down from the remote to your local. Okay. Let's jump on to ignoring files. Sounds mean, but it's important. The Git Ignore file, the .git ignore file, is kind of lurking in your repo if you create it on certain sort of web portals like GitHub. It can be created automatically for you and be blank, or you have to create it manually. So in our case, we're going to actually create a Git Ignore file. So first, what we're going to do is we're going to create a password file. So you can start doing this now on your machine. So we're going to essentially pass in any fake password, and we're going to call it password.txt. And then what we're going to do is we're going to check whether Git notices that file. And as you should expect by now, Git will notice that file. And the reason it notices it is because you haven't told it whether you should track it or not. So it's saying, hey, I'm trying to be helpful. There's that file. And what we're going to now do is we're going to tell Git, actually Git, thank you, but no thank you. We're not going to track that file. So let's do that quickly. Echo fun, and we'll put that in our password file. And now we'll look at status. And we see that so it's password, even better. And the password file is now being noticed. And what's Git saying, do you want to track it? Actually, we don't. So what we're going to do now is we're going to create a Git Ignore file using that same echo command, but we have to specifically put in the file name. So because I've got a spelling error, this is actually useful because it shows you that if I were to put in password.txt, this would be wrong because it would not actually ignore password.txt. I'm specifically going to ignore my password.txt file, and I'm going to create it in a .git ignore. And that's the file name. And then when I use my ls, if I want to see all the files, I have to use this -a argument. And the -a argument will simply show me that there's this .git ignore file here. All right. It also shows me the password.txt, but it shows me there's the git ord. And now when I run git status, see I'm lagging a bit, but when I run git status, now I'll look at what I see. I can see that there's this new git ignore file, but what's missing? The password.txt file is no longer there. And that's the important part. So now what we're going to do is we're going to add, I'm going to use the dot for shorthand because it's the only file. And I'm going to add that git ignore file to the index of tracked files. And then I'm going to commit. And the message will simply be add git ignore. And we have now made our commit. And as we've established, I would now push this essentially to the remote if I wanted to be on the remote. All right. If I don't push it, it will simply exist as a commit locally until I next run my push command. All right. So here comes the question that we've been asked already. Do I have to use my PAT every time? And the short answer is no, you don't. So secure shell is a much more convenient way to do things, and it works across the different GitHub and GitLab and other kinds of protocols like Bitbucket or whatever. So what we're going to do now is, you can do this too if you want to. If you have the SSH module installed, which you will on this, your virtual machine, but you need to have the SSH sort of modules installed in whatever component, either Windows or Linux or Mac that you're working on. But the command will be some version of create a key against my email address, right? So it'll be Gavin at fathomdata or fathomdata.dev, and I'll just use my email. And what you'll see here is it generates a public or private RSA key pair, and you just have to say what name you want it to be stored as. I don't really need it to be different from the default, so I'm happy with this. So if I push enter, it will take the default. It will also create a directory for me on my user where it stores SSH keys. And because this key is not going to be around once we kill NAC, once NAC gets closed down, this is gone. So I'm going to essentially not add a passphrase to it. And I now have, I click enter twice to skip my passphrase, and then I get this printout. And there's a lot to explain here in theory, but essentially you have a private key and a public key. And the public key is something that doesn't matter if other people can see that, but if you give people your private key, that's when things can really go horribly wrong for you. So you really have to keep your private key as safe as you can. What we're going to do now is, you essentially need to copy, right? So this is a sort of visual version of the key, but what you need to do is copy it, and we will specify the path to it so we don't have to go to that directory. But what I will do is I will cat, and then you've got to type this out. So it's essentially your home directory into your .ssh directory, and then the file name will be ID, because we use the default RSA pub. And oh, it doesn't like me. Did I do something wrong?
.pub.
.pub, thank you. Typos. Here we go. And there is my key that I can now, essentially this part, right? Everything here is kind of like gobbledygook, but the whole key is important because it tells whichever authentication system you're working on that this is the entire key, start, finish. All right. If I copy this, remember that now I should see that it is now on my clipboard. And from here, I need to copy it again. Right, so I will need to copy this again, but for now, I hope everyone's gotten to this point. So I don't want to rush on just yet until I know that people are getting to this point. Has anyone really gotten lost in the commands that we've used on the terminal? Seems good. All right, so what we're going to do now is, you see, we're going to go to GitHub and we're going to create a different kind of authentication through the SSH and GPG keys. All right, so you can see it's on my clipboard here. I will copy this. Inside my GitHub, I will now go to my profile, settings. I will go to this option here, not all the way down again. I'm going to go to SSH and GPG keys here under settings. If you open that, you can see new SSH key, and I will say NAC SSH. And now this is the important part. You have to paste that public key into this key field. And so it'll look like that when you've done it. Please do shout if you're getting stuck. I know that we're switching between systems and NAC gives you that one extra thing with the clipboard. So please just shout if you're getting stuck. Assuming you've done this, now you can say add the SSH key, and congratulations, you're done. As you can see, I have multiple versions of the key. I even have multiple NAC SSH keys, but they are different because the one got nuked the last time it got closed down. And what we can do is, now let me go to the big presentation. The way this works is we can authenticate ourselves using SSH when we want to interact with our remotes. All right, and the important part is that when we do stuff later on, like cloning, you make a decision at the point when you clone the repository as to whether you're going to use HTTPS or SSH. And if you want to use SSH, which I recommend, you will want to always select the SSH tab and copy that URL when you clone. All right, so let's jump on. We're going to do that now by creating a Git for data scientists or any other name repository that you don't have. And we're going to follow these steps to create a public initialized repository with a README. All right, so let's go to GitHub. I will now go to my repositories. So hopefully you're slowly getting more familiar with how you find places. You can come to your profile and click on the repositories tab. I see a question. Yes, Corentin.
Yes. Do you need to create a new SSH key for every project, or is a SSH key global to your GitHub environment?
Andrew, you want to take that one?
Sorry, Gavin, I was actually busy focusing on resolving an issue for Victoria. I missed the question.
No worries.
Would you mind repeating?
Yeah, the question is simply, is SSH global, or should you create a new one for each project? You know, how do you think about using SSH keys?
No. So you should think about the SSH key as something being attached to your personal identity. So, you know, you create a key pair, keep that private key private, and then you will share the public key into whatever resource you need access to. So, for example, if you're going to be using SSH with GitHub, you take that public key, pop it onto GitHub. If you're using it with GitLab, same story, the same public key onto GitLab. The only situation in which I might consider having multiple key pairs is if I have multiple computers that I work on. So, for example, if I have a laptop, I might have an SSH key pair on my laptop. If I have a desktop machine, then I might have a separate key pair on that desktop. But that actually will introduce additional complexity that is not ideal. In principle, I would want to have the same key pair everywhere, and that would mean that I can access the same GitHub account easily from my laptop and my desktop, etc. So you definitely wouldn't want to create one per project. That would be crazy.
And the key is temporary or not? Because I think the token is temporary, you know.
Yes, I think you can specify an expiry on your SSH key, but I mean, if you keep it secure, then there's no real reason for you to let it expire.
Okay.
Whereas for the personal access token, yes, exactly, it does have an expiry.
Okay.
Yeah.
Thank you very much.
On that note, I mean, when we look here at the SSH and GPG keys, I do have multiples for different versions of me, but they don't have expiries. Like, I don't want these to expire. Whereas on my personal access token, I'm happy to let them expire because I don't use HTTPS very often, personally. That's my preference. So, okay, so now let's get back to creating a new repo where essentially we will name it anything. Doesn't really matter. The key part is that we select public and we add a README. All right, so let's do that. We'll go to our profile, repositories, not find. We're going to click on the new button, and now I'm just going to call it use R 2022. Right, so it's a unique name. It's not used for anything else. If you don't have an idea of what you want to name it, it gives you a suggestion. That's fine. Public and add README file. The README file will simply have the name of the repository in it. It won't have anything else in there. You can choose a license or anything else here, and it's worth reading about what those mean, particularly if you make it a public repository. As you see here, the README is here, and it simply has this use R 2022 heading, which is the name. So now we get to the point where we've started our remote repository on the remote. And now I want to get that down to my local machine. And here we get to the point where I'm going to now have to choose how I clone, right? How I clone my repository. And cloning is essentially making a copy of it, right? With all the necessary links. And HTTPS is the one we were using with your username and personal access token. And SSH is what we're going to use now because we've set up SSH. When you click on the SSH tab, it gives you a different link. They are different if you click between them. And it's an important difference. And there's even a Git CLI, which you can use. But I'm going to use SSH. And now we have to do the little shimmy. So I have to Control A on my clipboard, paste in my repo over here. And I'm going to leave it there for a second and simply show you what we're about to do. All right, we've done that. And now we're going to talk about cloning. So cloning is to pull down that remote repository onto our local machine where we can make changes and work with it and then commit those changes by pushing them back up to the remote. So cloning is usually something you just do once, unless maybe you have to switch machines or something and you need a new version of that. Cloning is just a command you run when you're pulling down someone else's R package or something else and you want to play around with it. And the way you'll do it is, I can clear this. The way you'll do it is we're going to switch out of this version control project. Remember, we are inside a Git repository. So we don't want it to be inside that one ourselves. So I'm going to type CD space and 2 dots. And that takes me one higher up in the hierarchy to desktop. And now I will make sorry, I don't have to make a directory. What I can do is simply let Git make the directory for me by running git clone. And now I specify that. Is it not going to paste? Did I lose it here? Oh, that's why it's not pasting for me. I make sure it's on my clipboard. And then I see it there and I will paste. Hello. Am I going to have to write this out? All right, let's do it the manual way. I hope it's working for you guys. Basically, the structure is important because what you're doing is you're telling Git that, nice, we just lagged out. Now I've got a mess of a, just clear that. I will do git clone again. And I will paste. I'm not sure why that took a while. Hopefully it was faster for you. And when you hit enter, now what it's going to do is it's going to say, do you trust the host? And we do, because we know we've created it. We just say yes. And then it adds this host, right, with this address as a trusted remote location and a known host. And then it pulls down the objects into a folder, which is called user 2022. So the use R folder, if I just list the objects on my desktop, well, I won't do that, but basically I can change directory now into my Git repository. So whatever you named yours, if you also named it user 2022, use R 2022, here it is. And if we run our ls-a command, we see that it's got the Git folder and a Readme. And importantly, because we cloned the repository using an SSH URL, when we authenticate on this repository, it will use the SSH protocol. So let's catch up with where we were. We have done this process here. So essentially, as I mentioned, the important part here is that the choice of the clone link sets up the type of authorization and authentication that you will need to use. And if you clone it with the wrong protocol, the simplest choice is to simply nuke it, delete the folder, and then clone it again using the correct protocol. All right, so we've done all of this, and now we've moved into our repository, and we're going to make a change locally. All right, because now we're going to watch how easy it is to push using the SSH protocol. So let's go here, and we'll just pull this up so you can see it. We're going to create using the touch demo.txt. Okay, There's now a file called demo.txt inside my repo. Git status tells me it's new and untracked. There it is. And we will now run through our trusty stages of git add. I will use the dot because it's the only file. And I will then say git commit -m, and I will simply say add demo file. The commit has now been added. I can check what my remote is set up to be. So remember, we had to manually set up a remote last time, but this time, because I've cloned, I've already got a remote set up inside this repository. And it shows you that it's using the git@github.com URL, which tells it it's going to be an SSH authenticated, not an HTTPS authenticated remote. And then the last thing we do, and it's much more convenient, is to just git push. Now, what it's done in the background is it's compared my public key and my private key to confirm that I am the person allowed to do this. And then once it's confirmed that I am allowed to do this, it simply authorizes the transmission of my commit history on my local machine to the remote. Okay. All right. I see we're going on to about 1:15 my time. Does anyone need a break? We can discuss branches after we come back from a break. How does that sound to everyone? I'm also happy to keep going. If you feel like you still got stamina, if you're happy to. We good to go?
Maybe a short break would make sense, Kevin.
I think so, in case anyone needs the bathroom or anything else. Let's do a short one, 5 minutes again, and we'll continue with the really important feature of branches when we get back. I'll just wait another 30 seconds. Okay, I'm going to press on just so we don't run out of time to let people both get through all the content as well as play around a bit. This is an important sort of like feature of Git that I think it's easy to use Git and never really make full use of the branches feature. And by doing so, what you're essentially creating a risk in your version control system that doesn't need to be there. Because let's say, as I've explained in previous examples, let's say you just have an idea for something that may work, but you're not sure. Where is your safe space to go and work on your project that doesn't risk breaking something that you know is already working? Because you don't want the two situations where you're too scared to change anything because you've got it working, but maybe you'll improve your project dramatically if you do follow this idea and it works out. So you need a space where you can experiment safely. Also, you might have a bug or something that's been creeping in and you want to test your fix before you simply add the fix of that bug to the main project. So you want to make sure the bug is properly fixed before you just end up with a messy commit history of 65 hot fixes because you didn't have a place to test it other than the main branch of the project. So branches are what you use in these situations. And to show you in theory how it works is if the sort of spine of the project in this sort of example is essentially the main stable version of your project, and the commits here, which are these purple dots, represent the versions or states of the project that are stable and they work, mostly if in the case of bugs. Then when you do discover an issue or you have an idea, what you do is you branch off from this point of the project. So this state of the project, you branch away, you start doing your work, it has a unique commit history, and maybe the master branch or main branch continues down on its own development path. And when you're finished working on your idea, if you want to, you can merge your work back into the master branch. Or if it doesn't work out, you can actually skip this step and you just delete the work at this stage. And you never merge it back into the main branch. And that's what branches are doing. And if Andrew's working and I'm working at the same time, Andrew can be working from this state of the project, whereas I started working from this state of the project. And then we can use branches to simply manage how we reintegrate our work into the master branch. And that's why it's important when I said that a permanent record is how you would like to think of your commit history, because I shouldn't then decide to go and modify these commits because these are commits that Andrew's work may depend on, etc., etc. So it's an important thing to understand how, like, the commits that we're making, once you make your commit, you generally want to leave it as alone as possible. It's for the reason that branches may depend on that state of the project. And you don't want to break someone else's code without them understanding what happened. So that's the branches model. And now we'll see it in action. So to use and create a branch, what you will do is you will simply use the git branch command, and then you will specify the name. So let's go and look at our current project that we're in. So we're in our use R 2022 Git repository. And if I want to create a project branch that is now my development branch, so it's not my stable version on my main branch, it's my development branch, I run git branch and I give the name that I want the branch to take. It doesn't tell me anything. It just it is simply running again without error. But if I type git branch with no argument, it now tells me that there is a main branch and a dev branch. But the star, this asterisk, shows me that I'm on the main branch. And if I want to switch, I can use either git switch or this git checkout command that you'll see on your presentation here. and you check out. In other words, you go and you look at the state of the dev branch. And because it's no different, because there's no other commits yet to my main branch, it'll simply tell me switched to branch dev, and it'll now mean that when I run my git branch command, I will see the asterisk has moved and I'm on my new branch. Changes made on this branch will not affect the main branch until I merge. So let's do a demo here. Let's do what we've done before. We create a new file because this is to test our idea. We use touch, and we'll just call it new file as it is there. Touch the file, so it's created. If you want to look now, you'll see there's the new file.csv listed. Git status will tell us exactly what we expect, that there's a new untracked file. And we're going to do the git add, commit, and push. So git add dot, because it's a new file, git commit message flag, and you can be doing this at the same time as me. Git commit, we'll just say adding new file. There we get the confirmation. And now what we're going to do is we're going to git push. Let me show you this. If I just run the push command, what happens is there is no dev branch in my remote. So what it tells me is, hold on, I don't know where to send this commit history. So it gives you the helpful message that says, actually, you need to specify if you want the branch on the remote to also be named dev. In other words, you have to specify the set upstream origin. So this is the remote name, and you want to specify that the branch that you're pushing to on the origin will be the dev branch. So let's just do that. I see I'm lagging again. Git push set, and then upstream, and we'll put in origin and dev. And with no typos, you will see that it gives you a whole printout of what's going on, but it says that the branch dev is now set up to track the remote branch dev from the origin. So now you created the two-way link where changes made on the one can be pushed to the other on that branch. All right. And if you look at what's going on now with our Git log, and we just go with our Git log, we'll use a select the last three. What you'll see here is that you've now got this extra information about where you are. We are now at the most recent point on the dev branch, and the main branch is back at this commit. That's what it's telling you over here, that the main branch is still treating all the files as though they exist in this state. All right. And if we go back, so if we go back, or we use git switch or git checkout, and we type in the main branch, right, it tells us we've switched. And if we use the git log command here, and we just use, no, let's just do 2, you'll see here that it doesn't know about that commit on dev. All right, this is the add demo file commit, which is over here. And on the dev branch, there is the adding new file commit. And so they have now different commit histories. All right. And it's important to understand that this mental model is now in effect. We have now gone from the purple sort of state here, and now I have created this first gray commit on the dev branch. And when I move from the main branch to the dev branch, I'm at this commit. And when I move from the dev branch to the main branch, I'm at that commit, with the different states of the files. Because now if you look here, and I'll just clear the terminal, but if you look at the files, there is no new file .txt here. All right, so let's jump onto that exercise we see there, and you guys can carry on playing with more of these features. In many cases in Git, you're going to create just a specific branch for a specific purpose, like add this little piece of the UI to your website. And you're going to just create that branch, create that UI element, and merge it back in. And that's what we call a feature branch. So create the third branch on our repo using git checkout and then B. This is doing the same as git branch feature. There's many ways to get to the same end result. and add an empty text file, and then commit and push that to GitHub. As Andrew's pointing out in the chat, if you use the checkout -b feature, you will see that it actually switches you onto the branch at the same time as creating it. So you don't have to run git branch feature and then git checkout feature. Okay, hopefully it's gone relatively smoothly for you. Shout, ask questions in the chat, or raise your hand if there's anything not working. But I gave you a bit of the walkthrough of how to do that. We basically created a branch. We touched a file so that it got created. We added that file to our staging area. We committed it, and then I ran the git push, and I specified that I want the feature branch on my remote. My feature branch locally to be matching with the feature branch on the origin, which is my remote. And once I did that, I got my SSH handshake, and it sorted everything out for me. And now you can see that I'm on my feature branch here, and that I have this new feature commit, which is one ahead of my main branch. And remember, it still doesn't have my new file.csv from my other branch. These are now independent work streams. All right. And now we come to an important part of the branching workflow. Merging. And merging is an important way that, like, you've gone off and you've tested your ideas and you come back, and now what you need to do is you need to join your work from that branch into the branch that is the stable branch. Maybe it's the dev branch or maybe it's the master branch, but you are joining two branches together. So what merging does is it combines the sequence of commits that you have on the two branches, because they may have both moved forward in different ways. The merge will try to combine them such that there is now one unified commit history. And what it will do is essentially find a common base commit that it can use, and it will then look at the changes made to all the files that may have been changed respectively, and it will confirm that the head, which is the most recent commit on the receiving branch, right, is pointing to the correct merge receiving branch, and then it will fetch those commits across. So it's essentially doing what we showed in that diagram of bringing the two versions into a single timeline that can then proceed forward from that point onwards. So it's like you've branched off and now you're merging back in, like a road that sort of does its little sideways, tangent, and then rejoins the main road after a while. So let's just go and we're on our feature branch. We could do this with feature, or we can do it with the dev branch. Let's switch back to looking at the dev branch, and we'll see that we've got that one extra file. So we'll check it out, because using the command reminds us that we now switch and we get the latest versions of those files. So git checkout dev. I'm going to just remove the thing there. I'll do that again for you, or at least it is the git checkout dev branch. And now we have switched to it. And what we're going to do is we're now going to compare. Looking here, we've already seen that we have the new file.csv that we don't have in our main branch. So we know that's different from what's in our main branch. So we go to the main branch. So we are going to go to the receiving branch for the merge, which is our main branch. Now we're going to bring the dev branch's commit history to the main branch. So when we run git, let's just confirm where we are. See, we're on main, we're not on feature or dev. And we will now say we want to merge the dev branch's commit history into the main branch's commit history. And when you run the git merge, you are saying I want to merge the dev branch into the branch I'm currently on. And then it shows you what it does. If it's successful and it can do everything automatically, what it will do is it'll simply show you that it's made the changes, and it will have modified the commit history on the main branch. And now when you look at your files, you will see you have a new file.csv here in the main branch, because remember, that's the one we were on. And when you look at now the git log and we look at the most recent commits, what you'll see now is that the head, right, the most recent state of the main branch is the same as the most recent state of the dev branch. All right. And that's important, because now if we're done with the dev branch, we can delete the dev branch. If we still need to do some work of testing things and we want to have some more development options going on, which is usually the case, then you keep the dev branch running in parallel, and what you just have is these merges at regular intervals. And this is how you achieve that. Does that make sense to everyone?
Yes,
all right.
Thank you.
Great, thank you for the feedback. So now what we're going to do is we're going to say, what if it goes wrong? Andrew's a very, very active programmer, and he likes to experiment with lots of ideas, and he's touching all the files and he's making these changes, and I'm working on some other things and I've got my ideas going, and Andrew merges his branch into main, and then I come along and I go, oh, I want to merge mine. And Andrew's branch has created changes on files that I've also changed. And as now I'm coming to try to merge my branch into that, Git looks at the two branches and says, whoa, whoa, whoa. I don't know how to handle what Andrew's done and what you've done and make them a common commit history. You've both worked on the script.r file. Andrew wants it to go this direction. You want it to go in this direction, where something needs to be resolved here. That is a merge conflict. And basically, it happens in some subtle ways and some very obvious ways, but merge conflicts are not something you need to be scared of. Essentially, a merge conflict is simply Git saying, I can do all of these files and they can join the branch, but these two files, these ones have conflicts in them where you, the human, needs to make the decision about which version of that file is going to now be merged or will continue to exist on the main branch, for instance. And that's what a merge conflict is. So it sounds all scary, And believe me, it can feel overwhelming depending on the type of merge conflict that happens. But the point here is that merge conflicts are just a par for the course when you're using Git. And knowing how to fix a merge conflict is a skill that you can really benefit from. It means that the safe experimentation and all those other benefits we talked about with using Git don't make you think, but what if there's a merge conflict? Because that would really defeat the purpose of, being able to use Git the way we would like to. So let's create one. All right. Let's make sure we're on the main branch. You can start running these commands in the background while I'm describing this. Check that you're still on the main branch. And what we're going to do now is we're going to create this file merge.txt. And the merge.txt file is going to be the file we create the merge conflict on. So if you run these two commands, where you echo this line into the merge.txt file, and you run cat merge.txt, it will simply print back for you in the terminal this line. All right. If that goes smoothly, what you do is you're going to stage the file, because remember, it's not being tracked by Git. So you're going to stage the file, and you're going to commit it. You can say initial commit of merge.txt, or you can just call it the start merge conflict commit. And hopefully this is starting to feel very natural. You've got a file that's not tracked. We stage it so that Git starts to track it, or gets ready to track it. And when we say we are ready, it takes the snapshot of the file in that state. All right. So let me do that to catch up with you, and you can watch me do it again. So I'm going to confirm that I'm on the main branch. I am. I'm going to simply, I can't really touch. I have to create some content for the merge. So I will say merge conflict text. I'll create the merge.txt file. I will git add. Again, I'm using the shorthand because there's only one file. I will commit. I will use the default editor to remind you it's there, and I will say initial, I'll just say merge conflict. Oh, all right. We will write that. My message is there. And basically, what we're going to do here is I'm going to just go forward. We're now going to switch branches. So we're going to go git check out the dev branch. And remember, these are at the same point in time in theory, but our main branch has now moved ahead one commit with that merge.txt file. And so what we're going to do here is on the dev branch, we're going to create a file with the same name, but with different content. So now we're going to do essentially the same thing, echo. My content is header, and we're going to create a merge.txt. And now essentially the same rules apply. We have an untracked file because remember the Git branch we are on has never seen this file before. It doesn't know what's going on the main branch because they're not merged histories. So now we do the git add merge.txt. We do the git commit, and I'll just do it here. And I'll go merge conflict part 2. And now we see we have another merge commit here. And essentially what we're going to do now is we're going to go back to main and move it one more forward. So we go to git checkout main. Over here. So if you're following along on the slides, we're on our main branch. It's telling you here your branch is ahead of origin main by 2 commits. All right. So that's our remote branch. Don't get confused. It's not talking about relative positions of the other branches. So now let's create a situation where we add more things to that merge.txt file. So we simply say echo more content, and now use the double because we're appending it to the file. So we use the double greater than sign, and we append that to merge.txt. And what you'll see when you run cat merge.txt is that we have the 2 lines. You need to stage and commit this. And now we're ready to go, because now what we've got is a situation where we've created 2 differing versions of the same file in 2 different branches, right? Which is the situation I described. So when Andrew's made some changes to a file that I've also been modifying, and now we're going to have to try and figure out what's going on. So we're on the main branch. We'll confirm that. Yep, I'm on the main branch. And now what I'm going to do is I'm going to say, bring in the dev branch. But maybe before I do that, I'll just quickly show you here how they have different commit histories. I should do 1 line. As it gets longer, you really do need these summaries. So 1 line -4. Okay, so we've got the 4 latest commits. Head is pointing to the branch I'm on main, but origin dev is back here, and the demo file is also back here. So what we've done here is we've moved the different branches in different ways forwards. And as you see now, when you run git merge, Git is going to tell us that, hold on, the state of your 2 commit histories is not reconcilable. And you get this conflict warning. So it says in the merge.txt file, the auto merge of the state of the file on the dev branch and the state of the file on the main branch is not possible. And so what we need to do is we need to fix the conflicts, and then we need to commit what we've resolved. In other words, we need to commit the state of the file after resolving those conflicts. All right, so what we're going to do here is we essentially need to look at the state of merge.txt, and what you'll see is that there is this new text that's been added by Git. There is this head pointer, and then there is this break, and then there is this dev branch pointer over here. And it's telling you that everything above the equals line, these line of equal signs, is on the main branch. And everything below that until the next section break is on the dev branch. And that's how we set it up. And so what Git is telling you to do is, I'm not going to commit a file that has this structure. You need to resolve the structure of this file and then commit the modified version. So let's do that now. Vim or VI is just a text editor that you've seen me use to make my commit messages. And if you use Vim and you use the file name, you essentially will open your text editor with the text as it is in the file. If you're working in any other program, like in Windows, this would be Notepad, it would show you the same thing. Like, it's just a text editor. There's nothing fancy about this unless you get stuck in it. You know, it feels very fancy. But essentially, the text that we're looking at here is what we need to resolve. So if we push the I key, you'll see that now at the bottom, this insert happens. This is just a Vim sort of interface. And what we're going to do now is I'm going to essentially delete this component. I'm going to say, yes, I'm going to keep merge config text, and I'm going to keep more content. And I'm actually just going to add mine at the bottom. Oops, wrong line, sorry. I'm just going to add mine to the bottom of the file. And once I've done that, I will just delete. And there's various ways of deleting, but essentially, I have now deleted the tags that tell Git there's a problem in this file. And the file is now a single cohesive text document. And what you can then do is, if you've done that, if you follow along with me, you push the escape button. You'll see the insert. If you push I, insert appears. If you push escape, insert disappears. You're then going to push the colon key, and you're going to do WQ, which means write, and then quit. Essentially now, when we run that cat command again, you'll see I have 4 lines, 1 blank, but essentially all the text is there, and I don't have any of these warnings about what's going on inside the file as being potentially a conflict. All right, now we got to add. So we will now, let me look at Git status. Sorry, I'll just show you what's going on. The Git status will show you that both added, so in other words, both branches of the merge have tried to modify the merge.txt file. And if I'm happy with the state it's in now, which I've just checked, then what we're doing is we're going to now put that version of merge.txt in the staging area, and then we're going to commit that one. So we run our git add, and we'll run merge here.txt, and then we'll look at git status, and you'll see it's happy now. It says it's been modified. I can see that, but because you're telling me that this is the version I must track and get ready to take the snapshot of, I'm happy. And then what you'll do is you'll say git commit, and we'll just make a small message here that says merge conflict resolved. Yay. And essentially at that point, what we can do now is we can use, I'll just do this, we can use the git log. Well, let me show you git status again, because it's a really, really handy command to use. Everything's fine and dandy on our main branch. So it says, you're all good to go. And if we look at what happened and we use the log command, remember I said it's really useful, and git log to merge. Let's not do that for now. I don't want to mess around with the head state here. But essentially what we'll do is let's just use the git log, and we'll use the last commit here. And you'll see what it's done here is the commit that resolved our merge conflict is the most recent on the main branch. And it is the merge of the content from the dev branch that we created the conflict with. All right. So if you find yourself in a situation where perhaps it's not as simple a merge conflict as this, an important command to know is once you've run something like git merge and you've run the branch name and there's a conflict warning, until you resolve and commit, you are in a merge process. And so if you don't like being in the merge process, because maybe it's a very complicated merge conflict and you'd rather get back to some state that makes the merge conflict a little less severe, what you can then do is you can use the git merge and then flag abort. So you use the double hyphen or minus sign, and then you use the abort command. And what that'll do is pull you back to the state you were in before you ran git merge dev. So you can get out of that process. Once you type git merge, you are not locked in. You can abort the process. Are there any questions on that? Okay. All right, then I'll push on through the last little section, and then we are done. All right, so the pull request jargon that we talked about on GitHub. So when you're looking at a repository and you see this word pull requests, a pull request is essentially the idea that if someone wants to collaborate, right, pull requests help you collaborate on code with other people. So if I work on a local version on my computer of your project, but I think, hey, this would really help Andrew out, what I can do is I can then submit a pull request that Andrew, as the maintainer of that repo, maybe it's an R package or a Python package or anything else, he can look at my code and say, has Gavin done something that I want to include in my main project? And the pull request will essentially give Andrew the information. And it's like a merge request, except it's coming from a repo that's actually outside of Andrew's repo, in the sense that it's not Andrew's local repo and it's not Andrew's remote repo. It's my local repo or remote repo. And what happens is then I'm saying, do you want to include this change in your project? And then what Andrew can do is review the code, review the changes. And if he likes what I've done, he says, oh, that's a neat implementation. I'm going to include that. Then all Andrew has to do is review and accept the pull request. and it will update his commit history of his project on whichever branch I'm targeting with the pull request. And now I will have made a contribution to Andrew's project. So that's essentially what a pull request is. It's like a merge request when you're not necessarily on a branch within the same repo. A pull request is like it can be that sort of a merge approach, but it can also be like, let's say collaborators are working on different branches and they want you to review the code before it merges. That can be the case, but it can also even be for an entirely new person outside the project to contribute as well. And then what it means is essentially Andrew pulls the changes to the branch in the main repo. So essentially the important part of it is that there is a review and approval process in the pull request. So let's say, for instance, you go onto a repo that you really love and you see that there's an issue, and the issue is something that you think, I can solve that. And what you do is you then fork the repo. So you make a copy of that repo on GitHub. You pull that remote repo down to your machine. You hack away. You create a solution you like. You push it to your remote repo, and you create a pull request from your remote repo, the fork of that main repo, and you say, please, will you consider pulling in these changes to solve this issue? And that's essentially the sort of, in a nutshell, way that you see people contributing to these GitHub repos. You don't have to give everybody access to your repo with read-write capabilities. They can submit a pull request and you can ignore it, or you can deny the pull request or whatever on a public repo without necessarily exposing your repository to people being able to read and write on it. Trusted collaborators, sure, they can read and write on the repo and create branches. But for anybody else, like if I want to contribute to something in the tidyverse, I can go and create a pull request and say, hey, Hadley, I had a great idea for this. Why don't you consider adding my code? And if Hadley thinks, hey, that's a good idea, Gavin, Hadley can add it in. And that's essentially how you make open source contributions. And I don't know if there's anything else you want to add to that, Andrew.
No, that seems pretty complete, Gavin.
Okay, so essentially what we'll do now is we can create a pull request on a profile by simply using, if you're on your, let's say, I'll just show you how we got here, in your repo, whichever one you have in your GitHub profile. If you go from the code past the issues and you come to the pull requests tab, you can create a new pull request here. All right, and then it starts to tell you what you need to consider when doing it. So the target branch for this pull request will be my main branch in the repo, and I will choose the feature branch. And when you go to your feature branch, if we've left it the state mine was in, what you'll see here is that the feature branch has one commit that's different to the main branch. And I'm saying to someone like Andrew or even myself, I want to create a pull request that says, consider merging my feature branch into the main branch, because I think I've added a nice new feature here. And it shows you that there's one commit's different, one file has been changed, and one person has worked on this branch, and it was me. Essentially, you can click on all this information as it goes. But essentially, what you're going to do here is you'd say create pull request. You might leave a nice description, so new feature to authenticate, something like that. So there's a new feature for authentication. You explain, you say, hi, Andrew, and this feature, blah, 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 and goes on and on and on, and you explain what it's doing concisely. Andrew will read this. When he looks at the pull request, Andrew can then look at your code changes, and then Andrew could do something like saying, yes, I approve. And so once you've created the merge request, it exists now, and it's listed as open. So this is an open pull request, which is why the number 1 appears. And until it gets closed, it will exist there. But because we know that the feature branch added an empty file of a different name called feature.txt, what I'm going to do here is I'm going to say merge the pull request. And I'm going to say, do I want to change the message? I'll say yes, I will. I'll say authentication by SSH. And I will then say merge. And what will happen is you get this nice notification that your pull request was successfully merged, and now the pull request has been closed. You can then choose, if the feature branch serves no more purpose because it was a feature branch specifically about this, you can then decide if you want to delete the branch. In this case, I will delete the branch. And what you can see here is that at the end of the process, we have no more pull requests visible. But if I go back to my code, what you'll see here is that the main branch now contains the feature.txt file. And you can see that it was added as the new feature commit. And on the other branch that it existed on, we did it 28 minutes ago, but it's just been recently added under the merge pull request #1 from Gavin Masterson /feature branch. So the most recent commit here shows you what happened and added the feature.txt file. And if you look at our branches, you'll see that main and dev still exist, but the feature branch is no longer there because we deleted it. All right. So, congratulations. You've completed the intro to Git and GitHub. That's all I really want to teach you today. I know that's been a lot maybe to get your head wrapped around in terms of the mental model, but maybe the last thing I'll do before questions, and I'm happy to take as many as you want to ask me, is I'll just show you quickly, sorry for the flashes, but I'll just show you quickly that first diagram here of what we did today. So when we work on a local file and we make a change, as long as that file is either in a modified or untracked state, it is in our working directory, and Git will flag it under the Git status as a red modified or untracked file. A merge conflict file will also be shown as a both modified file. In other words, both branches have modified this file. You need to do something about it. When we are happy with the state the file is in here, we will move the file into the staging area using our Git Add Command, at which point we are essentially getting ready to take that snapshot, which will become that, like I said, permanent version of the project. We are going to take the snapshot of the file in that state. And then what we'll do is, once we're happy that we've got all the necessary files that maybe relate to that change, for instance, you've updated an R Markdown document, but you also want to have the .md file that it generates when you knit, or you've got an R script and you've got the data file that the R script generates, and you're tracking both of those. You put both of those in their new states in the staging area together, and then we move on to the commit stage where we say, Git, take the snapshot of the files like this, and you attach the message, and the message tells you why you made a change. And then what happens is, at the end of entering that command, the Git will automatically update the .git folder with the new objects as they exist. And it will create the unique ID for that commit. And for the rest of your project, unless somebody nukes it, you can track it. And that's basically what we're doing with Git. The only extra feature we added was, because you can work entirely locally, but of course, if your laptop were to have coffee spilled on it, your local repository would be destroyed because your laptop was. So your only extra version of safety that we added with this tutorial was the GitHub remote repository. And essentially, some companies will use remote repositories that are their own servers because they can't put them on public profiles where they're at risk. So they have them on their own internal servers. But essentially, the remote is somewhere else. It's either another directory or whatever. But that's the only extra layer of complexity we added to this. And when we have that extra layer of complexity, that's where we talked about pushing and pulling, because that's where we take our local repositories commit history and we push to a remote like GitHub, GitLab, Bitbucket, or whatever else you use. So there we go. I will leave it there and say,
yeah, Gavin, if I can just add in two things that occurred to me. So you covered the pull requests very nicely, but it's maybe worthwhile mentioning, and maybe you did and I just missed it, that you can add collaborators to a project as well. So you can basically then have like the inner circle. These are people who are working on a project. They can actually push directly to the project without going through the pull request procedure. And then you have people outside the project, and if they want to add to the project, then they have to submit a merge request. So if you're working closely with people and you don't want to have to keep on processing these pull requests, then it's definitely worthwhile adding them as collaborators. But you definitely wouldn't want to just do this to random people, because they're going to end up contaminating your code base. Also, with regards to merge requests, I remember that when I started working with Git, merge requests were this great big scary thing, and they can be a huge problem. Sometimes a merge request can have so many issues in it that it's completely overwhelming, and you want to just get up and walk away. You definitely want to do everything that you can to avoid having a merge request. And so if you're collaborating with someone else on a project, there are a couple of things that you can do to minimize the risks of a merge request. And basically what you want to do is try and ensure that you are never working on the same set of code. So ideally, if you can be working on one file and your collaborator can be working on a different file in the project, then you're not going to have a merge request, right? Because merge requests always refer to changes on the same file. The other thing that can be done is if you're working on separate portions of the same file. So for example, if Gavin is focusing attention on making modifications to one particular function and I'm working on another function, then again, we shouldn't run into a merge conflict, because we're working on separate chunks of content which are not going to ever conflict with each other. It's only if you're ever working on overlapping content within the file that you're going to run into trouble. So just exercising a little bit of kind of developer hygiene and trying to ensure that you're not kind of treading on someone else's toes is going to reduce the likelihood of you running into some really gnarly merge conflict.
Thank you, Andrew. Exactly. And again, yeah, that just reminds me that I should point out that the reason the merge conflict gave us this message here, just to be very clear, is because in this version on the dev branch, this was line 1, and this was line 1 on the main branch. And that's why it's fighting with each other. If this was line 3 on the dev branch and there was only 2 lines on the main branch, it would just add it as the appended line. But because the merge tries to take this line 1 and says, hold on, I don't know how to make this line 1 and that line 1 match up. That's why there's a conflict, exactly as Andrew says. And it doesn't show you the line number conflict here, but that is exactly why it created a merge conflict. So thanks, Andrew. And congratulations, everyone. Thanks for sticking with me. That is the end of the presentation, and I'm very happy to let you continue hacking away remember on Knack, you're safe. You can do anything you want. You can't break it. Play around, make commits, set up a merge conflict if you want to do that for a little bit of time. I'm happy to answer questions. But thank you very much for joining this tutorial. It's always a pleasure to teach about this really important version control system. And I do hope that if you've never used Git before, you're very excited to get into using it. And don't forget important things like have the cheat sheet open, maybe print it out. Just remind yourself about commands and how they can be used in different ways. Add understanding a little piece at a time, and you'll find yourself really being impressed at every level, but how much you can do with Git, and particularly with the remote platforms like GitHub. Fathom as a company, we use the remote platform of GitLab to essentially, that is our company. Like the intellectual property that we have is hosted on GitLab. Without that, there's just Gavin's computer and Andrew's computer and everything else. Our company exists inside a remote platform like that. So it's an incredible tool to use, and essentially the more you can use it and the better you understand it, the happier you'll be when you're doing complex projects.
Yeah. It's worth mentioning that the learning curve is steep, and it's probably going to be frustrating initially, but it's well worth your while to just press on and get through those initial teething problems. And I think there's just one final thing that I would add is that get your SSH configuration sorted out. It's going to make your life so much easier. Because if I'm operating without SSH, then every time I want to push or pull, I have to provide my username and password. And basically, that's just an impediment to me using the tool appropriately. So get it out the way, get SSH sorted out, and then you can push and pull without even having to think twice.
Couldn't agree more. Let me just go to the end. There we go.
Gavin, have you spoken about the integration in RStudio at all?
I haven't actually. If we have time and interest, I mean, we are at useR, so I'm very happy to tell people about that. If there are no other questions before I move away from Git itself and the focus on Git, it seems like there aren't. So I'm very happy to fire up an RStudio instance, and you can do this inside NAC as well. I don't want to update right now, thank you. And yeah, let's just think about this for a second. Okay, so if I were to create an R project file inside a Git repository, then RStudio has integration which will pick up that I'm in a Git repository and help me with some UI tools. So if I go to File and I go New Project, and I want to create an R project inside an existing directory, I will now browse. You can do the same because it'll be exactly the same for you. All our Git repositories are on the desktop. So I'm going to go look in those. And I'm going to take my useR 2022 and I can see that. And what I'll do is I'll say open, and I will create an R project file, so a .R project file inside that. And now you'll see that I'm in a useR 2022 project, and where before I had a very sort of like standard RStudio layout, you wouldn't have maybe noticed, but this Git panel was not there, and now it is. And the Git panel here is essentially the UI version that tells me information about the project's state. If we just take a second to look at what's going on, the main branch is the branch I'm on. It shows me that there's feature, main, and dev. All right. And I'll just point out that the reason it still thinks there's a feature branch is because I haven't deleted my local feature branch. I've only deleted the feature branch on the remote. So it thinks there are all of these, and I haven't updated that. If you want to create a branch, you can do so clicking on that little icon, right? And you can sync the branch with the remote, which does the set upstream option automatically for you. Then you have other options here in terms of how you handle files. Let's say the Git Ignore or the R project file. You often don't want to necessarily include all of the files, but for instance, often this is a useful one if you want someone to be able to just open the R project file when they clone your Git repository. So if you wanted to ignore a file, you could ignore it by simply selecting this option. You would simply select the file like this, and you would ignore, and it will be added here to your Git Ignore file, and then it will be gone, but I won't do that in this case, so I'll cancel. The Git Ignore has not been pushed, so we could update the Git Ignore, or at least it's modified, which is what this shows. You also have other things where the green button is the push button, and the blue button is the pull button. Commit is when you want to commit pending changes, and the diff shows you the difference in the files. So let's just go to the diff now, and I'll show you what happens. Like I said, the UI tools have different ways of showing you things. The green lines are additions, red lines would be deletions. So in the Git Ignore file, you have these 4 new lines, and the .git ignore, in case you're wondering why it appeared all of a sudden, is it's created by the RStudio IDE when it creates the .r project file. And it's saying ignore these files. So ignore the .r history, ignore .r data, ignore .r user data, etc., etc. And that's why it's now this modified file. So if I go and I look at the user.rproj file, you can see here that essentially it's got the text of that R project file, and I can see exactly that it added every single line that currently exists in the file. So the last thing to do here is to understand that if I want to stage it, the Git Add command can be done by simply clicking here. So let's stage both of these by clicking on them. They are now staged. So that's the git add. And because I've staged 2 files, it would be the shorthand for dot. And I will say add.rproj project. Oh, apparently my R's and O's don't want to be in the right order. And there we go. So now this commit message is effectively my user interface for what else I was doing in the either my terminal text editor or in the terminal command line. And if I want to write a longer message to explain why, I could use more space here, and I could say, Andrew always likes me to include this file so that he can get started right away. And there we go. Now my commit message is ready, and when I say commit, it shows you that it has successfully done. You see the same message as what you'd see in your terminal. You simply have to close that, and now what you've got is, if I want to push the changes, because remember I've got these commits now that are 6 commits ahead. So your branch is ahead of origin main, the remote, by 6 commits. And if I want to push them, if I'm back in the diff, I can simply, it shows you here, I can pull from the remote or I can push. And I'll try pushing. I'm interested to see, yes, I was glad. I expected this to reject, because what's actually happened is, remember how we merged the feature branch into the remote? Now, RStudio is telling me, whoa, you can't just push to this main branch because you might destroy some commit history that's been created on the remote. And so you get this message here saying it's been rejected because the updates were rejected because the remote contains work that you do not have locally. And so this is a good way to show the reason why the best workflow to use is, before you are trying to push your local stuff, you would want to make sure that you've got the latest version of the remote branch. Because as I said, when Andrew and I work on a project, the source of truth is the remote project. And Andrew's and my local repos can be very different. So what I'll do first is I'll say pull, and the merge has been successfully made by the recursive strategy, because remember, all that was different was this blank feature.txt file. So the merge is very simple. Git and GitHub simply resolve it by saying, pull that feature text into your local repository. You're good to go. And now if we go and look at my file system over here, you'll see the feature text has appeared. And now when I try to push the green arrow for push, I'll just show you that it says push over here. Voila. And now if I go back to my GitHub and I go to my code, it'll show Gavin merge branch So it's essentially 42 seconds ago, this merge, in other words, the way it treats this branch was I merged the main branch down into my branch itself, and then I pushed the modified version of my branch back up to the remote. So RStudio has it built in, and VS Code has Git integration as well in different ways, and whatever you prefer using, you can find a way to do it. So the UI is very helpful because it shows you exactly which files you're choosing to stage. So it's like I said, if you have 16 unmodified or 16 modified files, but you only want to commit 4 of them on the same commit, you simply select those 4 files at this point. And then you commit on those, and then they will disappear, and then you select the next batch that you want to stage and commit, and then stage and commit. And it's a nice process to just manage that. And if you do want to, just to point out, if you do want to work from the terminal, let's say you just don't like the point click all the time, you can create a terminal. You'll often see console, terminal, and jobs here. And like, depending on your setup, this is obviously a Linux machine, but if you have installed Git on Windows, you can set it up so that the terminal opens in Git Bash, which is essentially like a small version of the Linux terminal that is Git integrated. And then commands like ls and other things work. So even though I might be in Windows in my RStudio, I can then use Linux commands at the terminal line. All right. I'm glad to see the feedback. Thank you, everybody, for attending. Hope we didn't give anyone a headache. And if there's any other questions, I'm very happy to answer them. Okay, this might be a personal or irrelevant question, but I am a curious student who wants to learn something from professionals. Which extensions do you use in your browser and do you recommend? Which browser are you referring to? Internet browser? Or are you talking about sort of the programs that we would use for our development? I think in lieu of a more specific answer, what I will say is that you can work in the browser. There's nothing wrong with, you know, working in the browser. If you need a lightweight setup, for instance, and you don't have maybe your RStudio is not installed on a laptop, or you need to borrow someone's computer and quickly fix something, you can create a new file and you can sort things out online. So you can absolutely work in your browser, and you don't really need much else to help you. But you don't always get the benefits of working in an IDE because you don't have that extra sort of like program language support or something else. So you can name this like, you know, myanalysis.r. But the challenge in working with this is that you're kind of going to be having to work with code from memory. So you're going to have to start doing things like, okay, well, I'm going to pull in the tidyverse, and now I'm going to have to start writing my code. So hold on, was it sys.date or was it sysdate? And so you kind of end up in situations where maybe you don't remember exactly which sort of how to write a command or two. And you know, you can absolutely work in your browser almost completely extension free. And I've never done or looked for any particular extensions to add to Chrome. But what I do find is that, like, working in some of the other applications, even if you just want to work in a text editor such as VS Code, like VS Code is essentially a text editor that has Git integration. You see, there's the Git integration here. So if it picks up that you're in a Git folder, it will just integrate automatically. And VS Code is a lovely text editor if you don't have RStudio available to you, or you're working on a non-R project or something and you want to do that. There's a lot of different ways you can do it, and it's lightweight as well. So whatever gets the job done would be my sort of answer to the question. Using the tools available to you and just getting the job done. Some things will make it easier, but working completely in this setup means that at the bottom of this, you just commit the file, and you can either create the new branch so that you can run a pull request, or you simply run it on the main branch.
Gavin, I wanted to just mention a cool thing on GitHub. Yeah. So I've just sent you through a URL for emaili. If you wouldn't mind opening that up in your browser.
Let's see which browser it opens in. Okay, hold on. Let me get it quickly.
Actually, in any old GitHub repository. Okay, perfect. So that's going to go and open the GitHub repo. Now, if you go to GitHub in that URL, and you just put a 1S at the end.
Yes. So what we've done here, once it opens, is Andrew can explain it, but maybe you can guess.
So this is very cool because it basically it opens up VS Code in your browser in GitHub, and so you've got a complete development environment in a browser, so you don't need to install any of this stuff locally, which I think is super handy. And you can do this for any repository on GitHub. You just put a 1S after the GitHub in the URL.
And as you can see here, like all the different files that Andrew has made available in the public repo, you know, these are all here for you to look at. So I can look at any version of the file. I can see that this is exactly what it does. I can look at a function or two. I can see how Andrew structured the function, read his code. And essentially, as far as I understand it, Andrew, and correct me if I'm wrong, the 1S way of doing this is to give you a better browsing experience that you may be more familiar with, but you don't have full VS Code functionality as far as I understood it. There were some limitations.
Some limitations, yeah. But I mean, for quick and dirty fixes, it's pretty hard to beat.
Exactly. And I mean, like here, you would have, you know, oh, there you go. There, I found one. Cannot edit in the read-only editor. So in other words, I can't go and now edit this file directly. Because remember, even though I'm viewing it, this is not my file on my local repository. So I can't make changes. So even if I'm typing, I can't modify the source code of the repo. But if I fork the repository, this can give me a reason to do so. So I can browse Andrew's code and say, oh, wait, we could fix this. Like, this doesn't have to be NA. There's a different way we could do this. I can create my own fork, create my own local copy, and create a pull request. Yeah, thanks, Andrew. That's a really great feature, and it's a more recent integration. So just to be clear, it's the 1S at the end there, if you didn't see me put it in. Any repository that's public, you can just do that with a 1S, or even your own. Okay. Well, I think in the absence of any other questions, maybe we can say thanks very much for participating. I'm so glad this tutorial was a popular one. And I see another hand. Corentin, yes?
Yes, so thank you for the presentation. It was very clear. And I had an extra question. So you say that SSH protocol is pretty good, a good way to go. But I've already cloned a repository with the HTTPS way. Is there a way to edit and to make it an SSH protocol? But I think the meeting will close now in 30 seconds.
No, that.
No, okay.
We can definitely do this. So, Gavin, if you want to go ahead, or I'll happily take it.
Go. Yeah, you go.
Okay. So, I mean, it's just I'll just type into the chat what you would need to do. Quarantine is you do first you need to break the connection between your local and the remote. So you do git remote remove origin, and that would essentially break the link. And then you would do git remote add origin, and then where I'm putting the dots, you would then put the SSH link.
Okay.
And so that would break the HTTPS connection and insert an SSH connection.
Okay. Okay. Thank you. I will try it.
Yeah, that's if you remember what I showed you here on any of your Git repos. Just to remind you, when you search. Like Git, so you search git remote -v, or you list them, right? The URL is essentially tied to the name. So what Andrew's essentially doing there is you essentially remove this and then you re-add it. So it'll say HTTPS in your repo, and you're just removing it and re-adding it with the correct URL so that the authentication protocol changes.
Okay. Thank you very much.
Okay. Nice question. Okay. Anyone else? Brilliant. Well, again, thank you so much for attending. And it's always fun to give a presentation on these things to people who are interested in learning. So thank you very much for attending, and I hope you do wonderful things, and I hope to see you contributing to some of the tidyverse on GitHub soon. And, you know, wherever we bump into each other, you can follow people on GitHub. It's like a social media platform, essentially, in that way. You can see what people are working on in hobby projects. So check it out. It's a great way to build a portfolio and develop your coding and open source contribution career. And all the best. And yeah, thank you, everybody.
Cheers. Thanks very much. Bye.
Cheers. Bye.
Thank you so much. Bye.
You're welcome.
Thank you. Bye.